to Victoria Station, another show coming up. It's going to be a huge show today. It's going to be a continuation about the biology story, but a lot more thorough, a lot more into the quantum realm, a lot more examples what to do, how to make things. Today is also going to be how to water plants to make the best ketchup possible, with sugars, with many things to make a tomato that's highly enriched, gives health and everything, but it's going to be the tastiest, best ketchup, and so on and so on. Tons in today's show. The physics that it's all going to be about is biology today, and I thought to mention about that. I know people are not familiar with it, have not heard of it, because I'm the one that taught it up and I haven't shared it with anybody that much. I have a tiny little bit, but this physics about enriching food, about making people live longer, live healthier, be young for a long time. This is actually the best physics that ever happened to the human race ever in all human history. Yes, I have not explained it like that. I don't like to say, you know, to get people's hopes up, and people yet don't know about it, don't have evidence, and so on and so on. And people might even not believe it before they see evidence, of course. But in the shows, there will be tons of evidence, tons of explanations about the quantum realm. But in the beginning shows, I'm thinking to concentrate first on food, because it's an important part of everything and so on. And people have not heard of my physics yet. I know that. And I have a physics that knows every single thing, every single technology, every single plant, every single food, every single thing. I know people would right off say that's not even possible, but I have discovered the physics, wrote it down where it really is possible. Every technology, every type of food, how to know everything properly through the proper physics of it. Yeah, a big deal about that is knowing the quantum realm. That's one of the equations I mentioned that I wrote many years ago. It is temperature equals mass times quantum entanglement. Temperature gives quantum entanglement. That's how matter forms. All solid matter, food, medicine, technologies, phones, planes, yada yada yada, electricity, the wires, anything, it is quantum entangled atoms to each other. All of them have different chemistry, all of them have different energy in them. Some are dark, some are light, some are cold, some are hot, some are visible, some are invisible, so on and so on. But all solid matter is quantum entangled. Once a person understands that, then he knows how to quantum entangle atoms to each other. That means he can make anything, any technology, any food, anything he wants, because he knows in the quantum realm how to do that. And the other part of the equation is temperature. And temperature gives you how to make all those things. All of physics, everybody wants to make the hottest temperature. You all heard of course. You all heard, of course, about the fusion reactor. That's to make the hottest temperature on Earth. Although I believe that'll never happen, because fusion actually is attempting to copy the sun, but the neutrons in hydrogen can't really turn into plasma. Protons can, but neutrons cannot. I think that's a whole mistake. But people are trying that, but it will not be as hot as the surface of the sun, but sort of. But it has neutrons in it, so that won't really work out well through my research, what I thought about it. And you all heard about liquid nitrogen and so on, of course. So temperature makes matter. That's the huge on the entire universe realization. So that's like a one fast equation that explains that. Temperature gives you matter, gives you technologies, gives you food, gives you this, gives you that. Why do most plants on Earth give the best fruit in the summertime? Because they need a proper temperature to entangle and to make all the vitamins and tastes and so on, which happens in summertime. So it needs a proper temperature to be made. So just like in technologies, in steel and so on, that's how tomatoes are made as well. Thought to point that out. But in food, food gives us life, food gives us health, food gives us to live. People will see through this show how to live for 1,000 years and everything. It will all be explained and shown them and everything. But food is an important part because food makes us. We know how to make phones, planes, computers, but people are all bad, not doing so well in making other people. Everything on earth is going forward. The technologies, the science, the physics, the schools, the medicine, the everything, sports, whatever you want, people are making it go better and better and better. Freedom, democracy, everything is going forward in a good way. And one thing that is actually even a lot important is going down like the worst way ever. And that's food and how human beings are made. Of course, when people think about food and people and so on, they don't think about that as a science or as a technology. I love to see plants and food and things as technologies. To me, a plant is not some farm or something. To me, a plant is a technology that I'm making out of special parts. I choose the atoms, I choose the temperature, I choose how it's going to entangle, I choose what energy I'm making in every individual atom and so on, especially in the food. Today I'll show how to make the best tomatoes for a best ketchup possible. That's what I'm gonna, one plant I have decided to make just for a ketchup. That many tomatoes on it, 20, 30 are just gonna be that. And then there's gonna be another one for the best tomato sauce and so on and so on. Although for a tomato sauce, one would just need a very good tomato that others can, then other things are put in. But food is the very important part because food is what makes us. People don't know that a mother is pregnant. She eats food. But the food she eats is made by a factory. So that means in part that factory is making the baby in the stomach as well. Yeah, in the quantum realm, and yeah, they don't even know that, of course, but through scientific evidence and real good research, that's actually what's going on. The food the mother eats is in part making the baby. I mean, it is making the baby 100%. But of course, mothers eat healthy food. All mothers know that. But a lot better food can be made and so on. So in the shows, there will be tons of evidence and everything. I know many people can't really believe something before they see evidence. So especially if it's something so great to live for 1,000 years. But there will be evidence and people can try to make these foods on their own, of course, as well, and see for themselves. Because people believe something when they see evidence. Somebody might think it's wishful thinking, this and that, but there really is evidence, and all of nature is evidence of it, that enrichment of food really happens, enrichment of atoms and everything and so on. In the past shows I mentioned accelerators, particle accelerators. That's something that I just a little bit went into, but there's tons more to be told about it. I explained the magnets a little bit, but the accelerator is designed to make it is also designed to have special lasers in it, although any laser can do that. And as the atoms are going through the accelerator, then there will be also lasers that are in the accelerator where the atoms move to fill the atoms with energy. So just like food is enriched with energy to give us youth and long life, the same way in a particle accelerator, antimatter and atoms can be filled with photons, lasers, to make the best fuel to go to space and everything. And this show also about going to space, it's going to be like a huge, many shows about that as well, but in the future, of course. And of course, if people in Europe, in the European Union, in the United States are interested about talking about that accelerator and that it goes into work and everything, of course the magnets are the most important thing. That are superconductive, have the most electricity, coldest and everything. That I pointed out in recent shows, but there are many other parts that would go into it. And if people are interested, they can talk to me about it, of course. People from Europe, from the United States, and so on and so on, because it's a very great thing. And that particle accelerator could give us the solar system very easily if it works out the way I planned it. Although I think I already solved most of the problems because I wrote that a long time ago and everything. And so, but for it to give us the solar system would be the greatest thing as well, just like the food would be the greatest thing that ever happened to the human race, to have the wealth and one whole solar system. Cities on Mars, cities on Saturn's moon, cities on the moon and everything and so on would be a great thing. Plus the wealth of the human race would increase that much as the solar system. There are so many even dwarf planets, new ones found out, who can also have tons of who knows what type of matters on them that we never even seen or heard of. And a lot of riches that will bring, and that will bring a lot new technologies and many possibilities to the whole human race. Gravity also I mentioned a little bit, but I have a whole map that explains the whole gravity and mass of the entire galaxy. And the accelerator is very important, but it too is designed to enrich atoms. So as soon as the accelerator makes antimatter can still go through it, and it is filled at the speed of light. It is filled with photons, special photons that have at a special temperature that make the antimatter bigger, and a lot bigger per second, because photons go at the speed of light. Everybody knows that. So they would fill antimatter with photons at the speed of light, which is also a great realization for the particle accelerator, and that would give us antimatter and fuel with which we would go all over the solar system like easy as pie. But of course, if that all works out and the particle accelerator goes into working and everything. To return to the food, today's show is going to be about biology and food and how to make the best food ever. In France, people maybe have heard, there are some special types of, like they say, new foods that are made out of some special volcanoes. Volcano ash, sorry, that are made out of some, and there are some like better food. But that is also just ash. Now ash is dark matter, everybody knows that, 100% dark matter, because all the heat burned out of it when it was lava. When something glows, that means the fire is leaving that matter and only ash remains. So the French are trying something with some volcano ash. I heard those stories, to make some good healthier food and everything, but that doesn't really help out much. This food that I'm explaining is like 1,000 times richer, better, and returns health and youth 1,000 times more, million times more than that even. But the French are trying something. They are attempting something. They found that ash that they see that they think it's something good and so on. So they are trying and so on. And I have some planted French potatoes that were supposed to be some good ones, but they're actually just good mostly for cooking, not really that much good for frying. But I planted even some very good for frying that I think are a lot better for enrichment and everything, because out of that I plan to make new chips, the best French fries, the best chips, but they're going to be for cooking, potatoes as well. And those shows will all be in the summer. Potatoes are growing hugely, very well. Every day the leaves get bigger and bigger, and the roots inside and everything. And those potatoes will be seen in a month or two during the summer, how they grow. But that French potato is maybe about the size of one hand. But I'm going to make them, they're going to be that big, because the atoms will be fully enriched and everything. And they will be tastier, but on the potatoes they will be very enriched and healthy. But on the potatoes I concentrated mostly just on taste, to make the tastiest potatoes possible that I could think up. And that's going to be the best chips, then French fries, so on and so on. Another huge, very good idea that I got, that I'm gonna start these days as well, and I will show, is to make a special chili habanero, the hottest one ever in recorded human history. But the reason why I'm gonna make it is to kill cancer. the energy in a chili plant is very, very strong. That's why when a person tastes chili, it's like hot, hot, strong, strong, strong. The reason why that happens is because the chili habanero plant enriches the atoms at extreme full energy. And that's why when a person tastes the chili, it is very, very hot. Because the energy in the chili plant, plus it's that special type of energy that is hot, but plus there is a lot of it in the chili plant. So one special habanero will be to kill cancer, will be an attempt to do that and everything. And then one chili, two of those chilies, if they are eaten, they might cure a person of cancer. Now cancer is just like quantum entangled some dirt, not dirt, but something dirty. Person doesn't wash his hands for 10, 20, 30 years, and he gets a lot of bad atoms in his blood which are dirty, and who knows what they are and so on. Some may be, who knows, but they get into the blood, and for some chemical and temperature reason those bad atoms stick to each other and they form a tumor that grows. Because so then those dirty atoms entangle to each other, but when extremely strong chili atoms come to it, they're supposed to, that energy comes into the cancer and makes it fall apart, which is a possibility. Some matter can do that, but that's going to be an attempt to do that with the chili. There are other things that do that a lot better, like let's say the internal parts of an extremophile bug, which is the vaccine for cancer. I thought about that and wrote about it like 15 years ago, discovered some of those things that extremophiles can cure cancer before anyone even thought about it. But that was just something I was writing about like 15 years ago, so to speak, 13 years ago and so on. But a chili can do that same thing, because an extremophile vaccine can prevent cancer but cannot destroy it. So an even stronger energy is needed than even the bladder internal strong big molecules of the extremophile bug that are in the stomach of it. That's what prevents cancer, because it breaks it apart, of course. You can understand that, because it's inside the stomach, that breaks apart the dirty food that it eats. But the chili I'm gonna make is gonna have extremely stronger energy even than that is the possibility. Also in today's show, I thought to mention a new molecule that I have come across to understand that it exists. And it would be called the H3N, which is nitrogen and 3 hydrogen. And water is H2O, but it is also nitrogen. It is also nitrogen with 3 hydrogen atoms, because oxygen molecule is actually also a molecule from some point of view. An oxygen molecule is a nitrogen atom with a hydrogen atom, will be the explanation of that. And that will be in today's show also coming up and everything. So also what I thought to point out is the roots of plants in this show. The roots of plants are also made out of enriched atoms. And the bigger the enriched atoms are, the bigger the holes are through which atoms go. So the bigger the root, the more atoms can flow through it. And the bigger the atoms, the bigger the holes inside the roots are. So some roots might take in 2 atoms, 3, 4, if those holes in them are bigger and bigger. And then the plants grow better and better and better. I have now the most enriched roots probably of any tomato plant on earth, most likely can be said. And they are growing, as you can see in the dinosaur plant, is growing very, very well. The plant where I put the tuna fish that I explained in the last show, it grew like that much in like a day. In like one day it grew almost 10 centimeters, very, very well and so on. But interesting thing is to say about that even the roots can be enriched and are good for eating, but are then bigger. The atoms are bigger, therefore the holes are then bigger in the roots, and a lot more things can flow in the quantum realm. Many, many more atoms at the same time. Also, what I thought to point out in today's video is the summer is almost coming up. And in the summer there will be videos under the sea, catching of fresh fish, new fish, catching off moray eels, and so on and so on. Which will be with like a GoPro camera, will be videos underwater and so on, which will be in the shows, but also what to do then with those fish. And one thing that I have come across to understand is to take brains of fish and to water one plant, tomato plant, with just brains of fish. And then that tomato will be made out of enriched brains. So that will be like a brain atom that has a lot of good energy in it that is supposed to make people feel better and feel like young and so on and so on. But it will be enriched around with tomato energy. But that will be a tomato, just somebody wants to feel like a kid, feel young again, feel full of energy, happy and so on, fall in love again like for the first time, go through those feelings again. Well, that can all be returned as well. But I have not yet done that, but that's going to be in the summertime. But that's also to point out, fish heads are all thrown away. All the restaurants, farmers, they take the meat, the heads they throw away. So people can even find fish brains, they can find them for free. Somebody might even pay you to take them out and throw them in the garbage. You just take the brains out and you water a plant with that. But that will be like a special experiment. It will be in the summer from fresh fish from the sea and moray eels and so on. But a special tomato will be made just out of brains of fish. So another cool idea. But that also points to explain how big this physics is and how many things it has in it. It can even return that people feel young again and so on, to look young, but even to feel young and everything. Because in the atoms of brains of animals and fish is the energy of the brains, of course. And many people are missing that energy as they get older and older and older, and people don't even know that. But tons of that energy is in brains of animals and it's just thrown away. Every day nobody eats brains, of course. But in physics it seems like a very good idea. Another thing that I was explaining in the past video about biology is sharks. Sharks, dinosaurs and anacondas. And I told that only in the Amazon anaconda can live because only there are good enough atoms for it. And there is tons of evidence that actually supports that. People have in the past caught white sharks, big white sharks, to put them in zoos to attract visitors to see great white big shark, to see it in the flesh, to see it in an aquarium. But as soon as a great white shark is put in an aquarium, it dies. Nobody can do that anywhere on Earth. But the reason why it dies is because they give it our food. That's why the shark dies. It's through my evidence and my physics I have come across many such explanations in biology and everything. But that is obviously what is the case. They feed the shark fish and shrimp and so on, big fish, but the shark still dies. Because the shark in the sea goes to the deep, especially great white big sharks that are very big and old. And they eat some enriched things, we don't even know maybe that it exists. 90% of the ocean is still unexplored and the species in it. So the great white shark eats something that fish and shrimp, to it is like junk compared to that. To us, fish and shrimp is some of the healthiest things we eat. But to a shark, that's like junk food, like McDonald's, one would say, and so on. And the shark dies. And the reason why the shark dies is because the shark is used to eating enriched better, way better atoms that they can give it when it's in a zoo and so on. And then anacondas as well. Anacondas only live in the Amazon and they only know what they eat. Now that would be cool if there were special cameras around the Amazon or on anacondas that can follow them, or great white sharks, but they're mostly hunting in the dark most of the time. That would be a cool idea to see, because with their mind, a great white or an anaconda chooses what it eats. So nobody decides that for it. They choose what they eat. and they probably know what they are supposed to eat genetically and naturally, and then that would uncover that great mystery. Because all great whites have died in zoos, in aquariums when it's in a show and everything. But then especially because we don't have any food good enough for it, and it's gonna die. Anacondas as well have been attempted to put in zoos and everything, but they die. That especially because we don't give them food that has atoms rich enough to sustain it in life. So that would uncover that great mystery and show evidence of that and everything. Dinosaurs in Ica, Peru, there were like carvings on rocks about dinosaurs, and they are maybe 5,000, 6,000 years old. In my physics, I see dinosaurs that they were not extinct by the Ice Age or a comet hitting Earth. They all died because there was no more food enriched enough to sustain them in life. So dinosaurs were huge, and they needed huge atoms to fill all their plasma and all their blood to live long and so on. So in my physics and in my evidence of the biology physics, I have come to see that and believe that dinosaurs just died 5,000–6,000 years ago because all the enriched food ran out, because the people took most of that for themselves and so on. And people started meddling into nature, cutting down forests, so on and so on, and the dinosaurs died out because there was no more good enough food for them, because they were huge and so on and so on. And tons of evidence supports that, and in future videos will be about that as well. So that is like the cycle in a forest. Animals eat fruits and plants. Then they turn that into waste, and that waste returns to the plant. And that's like a natural in a forest cycle that happens. Then animals are eaten, parts of them go into the ground, decay, that goes into the plants, and it's a cycle. Animals become plants, and plants become animals, and so on and so on. But if we do that in physics, and let's say make an alpha forest, we can do that, but 1,000 times richer, 1,000 times better, and so on and so on. Now I have some plants that are made out of tuna fish meat. So however good that tuna fish meat was, now it's being enriched to become even better. And that's smart to point out as well. If some people are afraid about things going bad, spoiling and so on and so on. When a plant takes an atom, tuna, egg, cheese, milk, anything so on, it's no longer that. It turns into totally something else and preserves it to become something better and preserved, not spoiled and so on. Only when a tomato is taken off a plant can it start spoiling, and that happens because of temperature, and that's bad tomatoes that have not so good energy in them. They're made basically from waste or just water and ground and so on. Those are usually the tomatoes that grow bad. These tomatoes that I'm showing, as I see it in the future, they can stay on a counter like that for a month, 2 months, and they will not go bad at all. They will be fresh and good to eat and everything. So another thing I thought to point out that in blood and in plants, we all know in blood there is metals. There is a special type of atoms of metal that's in blood. Then in plants, some plants take in also a special type of metals in through their roots and into the fruits and into the plants and everything. And a metal atom is 30, 40, 50 times, well, it's 30 times the atomic number 30, atomic number 40, atomic number 50, while carbon is atomic number 6, water is about 20, water is about 20 particles, the water molecule. But an atom of some metal can be 60, 70, but they still go through the roots. So what I just mentioned also has evidence that a lot bigger, therefore a lot more enriched, bigger atoms can go through the roots. And the roots are designed that way, made, that they can make better and better foods and everything and so on. So those are going to be the things today in biology. Biology is a huge, huge subject. Like I pointed out, millions of different things. But shows will come step by step and so on and so on. A new molecule, which is huge to know because the greens of a plant are made out of nitrogen, that I can point out is very, very good and everything. Nitrogen comes also from water. When a plant is watered, and it turns into the nitrogen that is in the green of the plants and everything. So that also comes from water. That means that some water or some plants take some water and turn into that. So a water molecule can be really obviously seen and through evidence as well as nitrogen and 3 hydrogens, or oxygen and 2 hydrogens. But oxygen then is just nitrogen with a hydrogen atom. So in farming and in making plants, that's also huge to know, very, very important and very good to know and everything and so on. Because the hydrogen goes into the wood and the nitrogen goes into the greens, and that's how a plant grows. But there's even ways to enrich water, to enrich nitrogen and so on and so on. We can take nitrogen and pour into the plant, and then it will be a substitute for water and so on and so on. So great, great new things can come of the whole understanding of this physics and everything. And one thing I thought to point out today, I got a new phone. I got a new phone in the store. The newest iPhone, that is the biggest and the very, very good one. It is 256 gigabytes, so the best one and so on, because I broke my last one. And somebody's calling me as if they knew, but I'll answer later. And I thought to unveil it, like, yeah, they do in some videos, they unveil phones and everything. So I got it today, and I thought to do that to show people just an interesting thing about technologies and everything and so on. So there it is. Today I turned it on, I bought it and everything. And people can see an iPhone is very, very nice. It has a nice pack, it has all these nice parts in it. And you sort of feel like it's something very, very great to buy a new phone. I love technologies, phones, TVs, I love that a lot. But I even researched these things. See, now this is glass that's a touch screen. So it's a sort of glass that's strong, but it has under it sensors that can detect where the fingers are. And then it shows the picture according to that. So it's a movable picture, but all the picture is, it changes the little pixels, what color they are, and so on and so on. And then it creates motion and so on. To make an iPhone, that's like very, very simple, easy stuff. But I thought to point out, this iPhone is actually about 200 years in the workings. People might think they thought this up in a year. They made a new iPhone, very, very cool one. You buy it and that's it. And this one's also very expensive too. But the big scientific thing about it is there was Maxwell, who first started working on electricity. Then there was Tesla, who first started on electricity. Tesla told people about the internet. Then it took United States about 70 years to go through all Tesla's ideas, and they turned that into the internet. Tesla told people about the internet in the 1915s. He told people you'll have phones like this and everything. So Tesla was really a genius. But and then when you think about it, to make an iPhone, this is easy stuff. You program some stuff, you put electricity battery in it. Lithium batteries are very good now, and so on. But to make an iPhone, this is like very easy, simple stuff. But I did research about the screens in the past that I worked on. And the screen, this is sort of like glass. Glass comes from sand, silicone, many, many different things. In the past it was made just from sand actually, and so on, glass and so on. Those are crystals in the sand. What I mentioned about the cactuses. Cactus takes these types of crystals, that's like glass, and turns them into the cactus. That's why it lives long, because it has crystals and rocks in it. So it can stay in the desert just fine. You can leave this glass in the desert, it'll be there for 1,000 years just fine, of course. But this glass is all about density. A diamond is also a similar thing. Diamond is carbon, but it is so tightly squeezing together that's why it's a diamond. And then it turns into a crystal. So all a crystal is how tight the atom is on the inside of it. And that's this glass too. And in my workings and research, I took, but I had then, I was writing about neutronium magnets, which are so powerful. Then a person could ionize this glass and he could turn this glass into a diamond like that. And this would be even bulletproof then. That too can be just if we make the best magnets that are 100,000 times more powerful than the ones today. And that's something that will be in the future shows a lot, and that's something I was working on for years and years in the past, how to make many things about electricity and many things about magnets and so on. Because magnets and electricity are actually the same thing. All a magnet is stationary electricity, like I pointed out in past shows. But this is an iPhone, see, beautiful thing. 1,200 euros you have to pay to get it. But it looks beautiful. It has, it's actually even a computer. You have the internet. You have so many things on it, you know. And an iPhone, this is just something we have for fun. To talk to friends, to go on the net, to see things and so on and so on. But let's say you take a tomato. When you eat a tomato, tomato gives energy to your body. It makes the body of kids. Let's say food, just a tomato. So why is an iPhone so advanced and so good and so expensive? This is about the weight of a tomato. You buy one tomato for like 30 cents. But you have to pay 1,200 euros to get this phone. In weight, they're about the same weight. But this is something we have just for fun. But tomatoes are supposed to give life, and they turn into our bodies. They make us, basically. Food, I mean all food, tomatoes as well. And then you ask yourself, why is that like that? And people make tomatoes the same way they've been doing it for like past maybe 3,000 years. Not iPhones. Every year you get a better iPhone. This is now the best one currently out there. But in about a year or two, there'll be a better one, and there'll be a better one, and there'll be a better one. And that's how we humans do things. We make everything better. With more time and more research and more work, we make things better, better, better. Which makes humanity great and smart and so on. But why isn't that done with food? Is the big, huge question one would ask. And there people can see it's like people are stuck. So that's why too these shows are very, very important and smart to point out and everything. That the same way an iPhone updates, so can a tomato. Let's say this year you have 5 times enriched tomato atoms. So next year you'll have 8 times. Then the year after that you'll have 12 times enriched tomato atoms. Then you'll have 15, 16. You'll have 20, and so on and so on and so on. So the same way an iPhone, it gets better every year or two, so can the tomatoes, so can the meats, so can everything and everything. And then so can the future generations be made out of richer atoms, better atoms, and so on and so on. So just have to point that out, but I'm taking it step by step. It's a huge physics. I'm doing plants now. In September I plan to start farms of turkeys and some animals, and that will also be in future shows and everything. But it's a huge field, and so I'm taking it step by step. So today there'll be about the plants, a checkup on them, and some physics about that, the quantum realm of them, and how to water a plant to make the best, tastiest ketchup possible. So the enriched ketchup that will not spoil by itself or anything, that doesn't need any preservatives in it, and the healthiest and the tastiest. So that's coming up in the show. So that's going to be the show today. A lot new things coming, and a lot more is going to be in the future. Technologies and everything and so on and so on. Physics, the best new physics about all matter in the universe, all known matter in the universe basically. And of course people might find that a little bit too much and everything, but really once a person knows the physics about everything, that is all encompassing. You all probably heard the scientists, they're searching for the theory of everything. What is everything in the universe and so on and so on. And I can tell you that right now. Everything in the universe is mass. Every single thing, physical thing in the universe is mass. Except thinking. Thinking is something spiritual and so on. Thoughts do not have any weight or anything. But everything physical in the physical universe is mass. That's a simple and correct, fast way to answer that. And every piece of matter is mass. And through quantum entanglement, mass and temperature go in all matter. They produce heat, cold, and so on and so on. So the physics is huge, huge, huge about food, about technologies and everything. And I'm sharing it because I mean, I love to share my physics, and the point of physics is to share it. Why keep it to yourself? I have so many ideas that it's like when I'm working, sometimes I think of 10 patterns a day, simply because of this physics that I know. Best laser, best this, that, does that. Sometimes I write down 10 of them a day. So there it is when I water it. That's the dinosaur tree right there, the biggest one and everything. It started giving fruit now, so tons of good atoms are going into the whole plant and everything. But that's what one gets when he pours all that in. It's got tuna fish now in it. It's got many eggs in this one watering. It's got tomatoes in this one watering and everything. Sort of like similar to the Amazon thing, but this is the one for the dinosaur tree. So it's got eggs in this watering, it's got tuna fish, it's got tuna fish is a substitute for carbon. Tuna fish is all 100% carbon, but when it's whizzed and poured in, that's what one gets, all this foam on top. Now most of this foam will evaporate into the air actually, because it's on top and it's not even gonna get into the roots. But the foam is the most important part that's supposed to get into the roots. So a person pours in this and then water over it. So when one gets foam like this, so people know when they do it, then you pour, let's say, a half a liter of water over this foam. Then you do it again and you do it again, how much water it needs, and then that's it. So that the water picks up a lot of this foam and carries into the roots. It is also in the watering as well, but a lot of foam stays on top. But all this foam that evaporates into the air, the leaves inhale that. So that's like oxygen for the plant. The leaves inhale all this carbon monoxide, so it gets into the plant anyways, and it's even like breakfast, you inhale it too, you know. But this is carbon monoxide, like sorta, but rich carbon and good, so it's good and healthy to inhale and everything. So but the point is that the most of this foam gets into the roots, not on top and just evaporate. And it is individual carbon atoms, so all of it will go into the root. But the problem is the tuna fish turns totally into foam, all of it. So then that's the important part, to get as much of it into the roots and everything. But the dinosaur tree has roots even on top, right there. The whole bucket is full of roots, like all of it. So that's what remains then. People can see there on top, some of that stuff remains. But because always some of the pieces are not thoroughly blended, some of the pieces of a tomato and of some things are, and of eggshell, they remain intact, bigger. Everything that goes into the root has to be a liquid. That's all that goes into a plant. Nothing bigger than that can go. Atoms could go into a plant enriched, so big ones, even 1,000 times bigger than our carbon atoms today. But if it's carbon atoms and atoms at all sticking to each other, thousands of them, well, that's these big pieces. Well, this is even billions of atoms sticking together still. Because some plants and some things have those parts of them that one would have to blend like for 2 days for it to break down into a liquid. But that's okay, that remains on top, and there is still some bubbles and foam right there. But most of it I watered in, see. So when you're left with this on top, then you just pour in half a liter and it'll pick some stuff up. Half a liter and it will pick some stuff up. And you do that all the way until you see that down there is water. When you see the water reach the bottom, that means it's all full and it's all good and all the roots are getting all the stuff they need. So there it is. That's what one is left with on top. A little bit reddish, some parts of tomatoes and some things. But when it is like this, then just water is poured in. So I'll just show people that. And usually it's all the foam I got in, now people can see. But still parts of it are right there. And then one just pours the water in a little bit. That much is enough. And now now the water will pick up more and more of those atoms. There one sees bubbles. That's the egg, that's the tuna fish right there. So that means still a lot of it is on top. Even if it goes into the air, the plants inhale it, so that's okay. But most of it is supposed to go into the roots. So first I pour in about 2 liters of all the mixed things, and then I pour in about 2 or 3 liters more, like this, little bit by bit afterwards, and then it picks up more and more of that stuff. That to ensure that it goes into the roots, because if it stays on top, most of it, then it's just gonna waste away. It's just gonna go into the air, or it'll just sit there, and then that's that. But that's how it's supposed to look when it's all done. I would, if these big pieces remain, they'll just get dry and sit there, and I just remove them. I take them away and I blend them again, and that's it. Because if it sits there like that, it'll just become dry and that's it. But the land should be clean and nice like that, and when it's all done and finished. So another thing that I have done these days, which is totally great and totally cool, the other tree right there is growing tomatoes. It has around 15 right now. Some are there. There are some that are just starting there as well, and so on and so on. On the bottom as well, there is 2 of them growing nicely. Flowers are starting there on that sucker. But the big point about this is that the tomatoes are extremely cold. I touch it like that, and it's like I'm touching something inside a fridge. And that is because there's extremely quantum entangled concentration of dark matter now in the tomatoes. It's got enriched carbon, it's got enriched nitrogen, it's got a whole lot of dark matter. That is the one that gives youth and everything that I explained in earlier shows. It's got a whole lot of that matter quantum entangling there to become a tomato. Plus it's got enriched water, because all the water I pour into the plants is blended in the blender, so mixed up with all the carbon and all the energy from carbon and everything. So that's how a person can know if you are doing this the way that I explained, videos and everything. You just touch the tomato. If it feels like it's in a fridge, that means it's working, and that's like the best thing ever. Number 1, it is cold matter, the matter that gives youth, gives life and everything, but in a very big and very enriched version, because this now has a lot of enriched even nitrogen in it. When a plant takes water, hydrogen goes in here, and that's not cold at all. That's in the wood. So that's where the hydrogen from water goes, into the wood. But the nitrogen goes into the leaves That's like maybe two oxygen molecules of water break down and they turn into nitrogen. So the greens you see, leaves, and especially the fruit, that's nitrogen. But I give it tons of nitrogen because the greens that I have enriched ones, I whiz them in the blender and I then water the plant with that. And then the colder the tomato is when you touch it, that means the better it is. So now it's cold maybe like 5 degrees, 7 degrees, sort of like that, maybe even 3 degrees, because by touch it feels that it's that cold. Sort of like when you get something out of a fridge, when you go for something in the fridge, well, it's about that cold, so to speak. And that is the coolest great thing because number one, it's very, very cold. It's preserved and it's the right energy in it that gives life and everything. Number two, that means even during the summertime, the internal temperature of the tomato is cold. That means it is like in a fridge, so summertime is not at all gonna hurt it or anything. Some farmers say they expose the fruit to sunlight. The fruit is cold matter. Fruit doesn't really need sunlight and it's not even good for it to be exposed to the sun. The leaves need sunlight. They pick up photons. The fruit doesn't need any sunlight at all. It's not even good for it anyways, because it's cold matter, like I explained. So the water breaks down when one waters the plant, although I give tons of nitrogen and all those things to the plant, but the water breaks down into hydrogen, and that's the wood, and into nitrogen, and that goes a lot in the fruit and in the leaves. So, but the leaves are also made out of carbon and out of minerals and out of many, many things, and the fruit and the plant as well. But this is like to explain from the water's point of view. So this now has enriched nitrogen in it, enriched carbon in it, and so on and so on. And that's why it's very, very cold, because all those atoms are entangling to each other to become the tomato. Plus it has the liquid in it, enriched water as well. And then when one touches it, that's like an H bomb would be in nuclear physics, but this is like would be the nitrogen bomb. So extremely, extremely cold. People know, one can see on research done that that some nuclear matter even glows in the dark, you know, because it's very, very hot. The internal temperature of the atoms of nuclear matter is extremely hot. So some of it even glows in the dark. But that's nuclear physics of bombs. Here, what you need is the tomato to be as cold as possible. See, when I touch it, I feel that it's sort of like inside a fridge. That's how cold it is. But that's now. The more bigger and bigger the tomato gets, the colder and colder it will get. Plus, all these atoms that one sees right there are now being enriched. So they are green, but they are being even more and more enriched with cold energy. And these plants have tons of that cold energy because they're made out of enriched carbon, eggs, and so on and so on, and greens and cactuses and so on and so on. And they have tons of that energy to enrich the tomato to make it even healthier, therefore even colder. So it is like the coolest thing ever in physics, you know. This is like nuclear physics, but taken 10 steps forward, you know. No nuclear physicist ever made a tomato that's something like a nuclear bomb. So it's like the coolest thing ever. When I touched it, I usually don't touch fruit because I keep everything above the plant squeaky clean, you know, and everything. But I just touched it and saw that it's that cold, you know. So that's like incredible. It's like maybe even around 3 degrees actually, around that temperature. So like the coolest thing ever and everything. But that shows right there, if people do this, you will see the same thing happening to your tomatoes. And just to point out, the colder they are, the better they are, you know. that means the more of that energy that gives youth is in them actually. So but it's like the greatest, coolest thing ever, you know. No nuclear physicist ever even thought up of this. So it's like the greatest, coolest thing ever, and so on. And there is lots of those tomatoes growing on this tree and on the dinosaur tree. The one is right there, also growing nicely, also growing nicely. It's getting bigger and bigger. But that's the one there and the one right there that are doing nice on the dinosaur tree. But the dinosaur tree has a lot of flowers fertilized, like ones there, so a lot of tomatoes on it are coming as well. A little bit slower than this one, but they're coming just as well. So, but the third plant has a lot of flowers now starting, some of them, but not yet fruit, but it will as well. So but that also shows the dinosaur tree is bigger and has a lot more greens, but it is giving fruit faster than that one. So but that's something people can watch out for. When you see that your tomatoes are extremely cold, that means you're doing everything properly and correctly. That means you have enriched carbon, enriched nitrogen, and so on and so on. And your tomatoes will be the healthiest, the most organic, the best tomatoes on planet Earth, you know. That's how a person can see just by touching it and realizing what the temperature, the internal quantum realm temperature of the tomatoes is. Now I touch the plant. The plant is not that much cold at all. It is a little bit cold, but it is not even close to how the tomatoes are cold. Now that is the best for health, for staying young, long, and everything. Number two, it is the best because even insects will not touch it. If an insect comes over to the tomato and he realizes how cold it is, the insects are running away like as fast as they can, because insects, they operate when it's hot and summertime and so on, as people know, and so on. So that's one easy way to know if somebody's doing this nuclear physics on plants properly. You just touch the tomatoes or any fruit you're making, and the colder it is, the better it is. So in part, this is like making a nitrogen bomb, if you like, but not a hot one that explodes, but a cold bomb that gives you the best health, the best energy, and everything. Now check this out. This is one of the leaves I left there to whiz, but I left it longer because it was dry and everything, so I didn't think to use it. I had better ones, but check out the color. That's a cherry plant, and this is like an old leaf from past times and so on. And it's all purple. I made a purple cherry plant leaf right there. And that's because it wasn't watered like a long time, maybe a month or something. That was the one plant I left because these cherry plants were a total mistake. I got these ones that don't even grow much. They maybe go a meter and that's it. But I was planning to make big plants, but I got these cherries from like a store. I just bought the cherry and planted them. I thought the cherries were good, but I didn't know that the plants were actually very, very tiny. That's those right there. They don't really grow much. That's the tallest one. But that's probably their genes. It's the type of plant that doesn't really grow much, and that's that. So they were actually a mistake because they're not big plants. And this is the one that I didn't even water. And now people will say, why is it purple and why isn't it dead? See, this one, this is a leaf that's cut off. And it was sitting there for many, many days. Even when it's cut off, but it doesn't want to dry away and die. And the reason why it doesn't, because it's made out of cactus atoms. So this purple leaf you see there, it still has moisture in it. And that's because, and it was sitting there for like a week and even longer. But the reason why it's still moist and still a leaf and not dry is because it's made out of cactus atoms. And cactus atoms have that type of energy in them that they can stay, have moisture and stay good long time. See, because that's a leaf that's cut off, but it's not dry. These are dry ones. This is from the cucumbers. But this leaf just doesn't want to die. It's like, plus it has a totally different color. So that's what I explain people. Even tomatoes we can make like this. Now if I separate one plant and water the tomatoes with cactus atoms, it will be sort of like purple. Yeah, it'll be a purple tomato, number one. Number two, that tomato will not need any preservatives or won't need a fridge at all. So that's the great physics about knowing these things. So one tomato plant I'll separate and just do it with cactus atoms. And this shows it will be a purple tomato. It will have some taste new that nobody ever tried before. And number three, it will not need any preservatives. Because as people can see right there, cactus atoms remain healthy and good cactus atoms full of moisture, but even without a fridge, even without any preservatives or anything, because preservatives are unhealthy anyway. And then that's a huge, great idea for, let's say, ketchup, tomato sauce, and so on. But the taste is also important. But one plant, now I'm figuring out I'll do that. I'll do a special watering for it just with cactus atoms. I don't have that many cactuses. I went around everywhere and was looking for cactuses that are not anybody's, that I can just take, chop leaves of them and take away. But I sort of spent all my supplies so far, but I'll figure something out. I can plant some of them around and use my own. But as people can see right there, that's a totally great idea, because the leaf is still full of moisture and it's like it doesn't want to die at all. And the simple explanation about that is this is cactus, because it's made out of cactus atoms. I could maybe even take this leaf, put it in the ground, and it might start its own plant. So I'm gonna try that now. I'm gonna stick it in the ground and see, will it start its own plant like some tomato parts do. Suckers do that, but the leaves by themselves maybe do not. But this is a cherry plant, that's why it's dumb. Because these cherries are extremely small plants, they don't grow much. So, but they're good for ketchup. I thought to make some great new ketchup out of it. So that's sort of the beautiful thing about this physics. People don't know about it. It's new, but it's beautiful. See, so this I'm gonna whiz it too and put it in some fruits and everything, because I have more of these purple flowers and everything. But now I know how I made them, you know, and I can make tons of them if I want to. But I'm gonna use it on a tomato, and then a tomato will be made out of these atoms, and then that tomato, I'll leave one to sit outside in the summer heat and observe how long it takes for it to spoil. And by my estimates, it'll never ever spoil. So that tells you as well, we can make food that doesn't even spoil. You make tomatoes, and they're tomatoes, good and fresh to eat for like 5 years. And that's the beauty of this physics. Then also ketchup. You don't have to put any preservatives. Although in ketchup people put vinegar and stuff that's not that bad. Even let's say if you take tomato sauce, which is something I plan to make in the summer. Videos will be on that. The best ever tomato sauce, best ever ketchup, tastiest, best, and everything. But now I know how to make the tomatoes that they do not spoil. They might be even purple, so we'll even have purple tomatoes in the future, because there's evidence right there. This leaf naturally is supposed to be green. That's from this plant, just a different one. See, so that one is totally purple and that one is green, and because all the moisture from the plant has gone. But this purple moisture, that is the cactus atoms still having moisture in them. And that's why this leaf is not dry and didn't die. The other ones would be like that. Dry totally, and that's it, because the moisture leaves, and that's that. That happens to most plants and everything, but not to cactuses. See, so that tells you that if I was gonna make a forest in the desert, although that's a lot of physics, tons of information in quantum realm, but this is evidence that it can really be done. So one plant would be made out of cactus atoms, a tomato plant, but a big one, not these cherry ones. And then I would make these extremely cold tomatoes. Because in the desert, even if it's very, very hot, the internal temperature of a tomato is like a fridge. It's like very cold. Plus, these tomatoes are now small and they are getting filled with more and more energy. So the more and more energy the atoms get, the colder and colder they will get. Because it's sort of like nuclear physics, but not in a hot, explosive version, but in an extremely, extremely cold version. And that too explains that nitrogen, liquid nitrogen, that is minus 300, that through this physics I can really make some of them that are minus 1,000, minus 10,000. That's also some of the plants I plan to make in the physics, in the experiments parts and everything. I plan to make tomatoes that make nitrogen for liquid nitrogen, to make them minus 1,000, 2,000, because that's extremely good and to me extremely useful in experiments and everything and so on. But to scientists all over the world, you know, all scientists are trying to make something colder than liquid nitrogen or liquid helium. But liquid helium there is a totally great idea too, because helium can fit inside plants and fruits as well. So can other atoms, but helium, liquid helium, is also extremely cold. So, but there's the evidence. All that purple people see, that's actually cactus. Right there. Even the vines in the lines right there, it sort of looks like it's like veins. But that's the similarity between people and plants. See, we have veins and we have blood in the veins and in the meat and everything. But the plant, that's its veins, is these lines. And the branches are actually those types of veins. But that's where water goes through, and carbon atoms and everything that the plant grows from. So what blood is to us, to the plant, that's water. But what enriches that water is the stuff that's in the plant. Because as the water goes through these lines, it picks up all the energy from the atoms that the plant is made out of. And then that's even how the fruit is made and enriched and so on and so on. So that even makes nuclear physicists, you know, it makes them look like, you know, they're little kids, you know, when they come home from school, like, Mommy, what's for dinner? You know, they just eat what's out there and what's given to them. But even nuclear physicists have not yet figured out that through nuclear physics they can make the best food imaginable, the healthiest, the tastiest, the greatest one around. You know, just through nuclear physics. But they haven't yet figured that out, you know, so. But, you know, people will know as the information travels and so on. But it's the greatest thing. But that's an easy, simple way to know in this whole physics and what a person is doing. You just touch the tomato. You touch it with your hand, you feel how cold it is. See, now I'm touching it and I'm thinking it's about, I mean, I can feel it. It's about 5 degrees, 3 degrees. Sort of like when you reach in your fridge and you touch something, well, that's about what temperature it is. But that's because it has enriched nitrogen and enriched carbon in it. That's the reason why it's like that and so on, and they're all like that. So that's an easy, simple way, you know. You just touch it. You can get a thermometer if you like, but then you have to stick it inside and poke through the fruit, and that will mess it up. That's not really good. But a touch thermometer, that's good too. But the internal temperature is what's very important. Number one is you're getting the best fruit, then the most enriched, the colder it is. Number two, the summertime will never destroy it because its internal temperature is extremely cold compared to the outside temperature, which is very hot during the summer or in a desert or anywhere. So that's just evidence too that in deserts tomato plants can be grown just as good. With the whole thing that I just explained, which is sort of like a beginning in that, but a whole video, whole show will be about deserts, how to make the whole plant, what to water the fruit with, and so on and so on. And this sucker is doing very well. So it has right there it has flowers, right there it has tomatoes that are starting and flowers, and right there are those that are already growing. It has 5 tomatoes now, and this leaf 2 is like the last one. This little one though is not growing, but that will start probably in the summertime. But that is like an easy, simple way. One just touches the tomato. I can even feel the cold coming out of it. Like when you touch something very hot, I can feel the cold energy coming out of it. So and that makes sure that insects run away from it. Bugs and so on and so on. As soon as they feel something so cold, they run away, you know. So it's best for like multiple things and everything. So it's going extremely well, as in my physics I planned that out to be. But the whole point is it's enriched dark matter, it's enriched carbon, it's enriched nitrogen and so on. Nitrogen one gets when he gets the enriched greens, and then in a blender blends them and waters the plant with that. Cactuses too have tons of nitrogen and so on. But cactuses are more made, well actually cactuses do not have that much nitrogen, probably because there is not much water in deserts. I mean ones that are not watered, the ones that are watered here, they do of course, but in deserts not. But they're made out of minerals and rocks and everything and so on. So that's why this leaf didn't really die. And it's still okay, and it's purple because it has tiny little yellowish parts there. Because this is rock right there. This is atoms of minerals and rocks and things and so on. So it's how cactuses work, their roots, how they pick stuff up and so on. So the easy simple way to know things is one just touches the tomato and feels the cold energy coming out. And it feels really cold, these, but in the summertime they'll be even colder, because even these are getting filled with energy right now, and in a month there'll be a lot more of that energy when they turn red. But which color they will turn into, we'll see, because that depends on the chemistry and on the atoms that are in there and everything. So maybe these won't even be red, but the original the gene of the plant is that they are red, they become red. But they have many atoms different in them, so color will be seen in the future, of course. But that's just to point out those easy simple ways to know. One just sees the temperature of the tomato and then he knows how good it is. The colder it is, the healthier it is, you know, simple way to know. And this is the part where all the leaves are turning, where all the flowers are turning into tomatoes. There is 11 tomatoes right there. 3 are the big ones that are seen, and all these flowers are closing, fertilized and growing. The green part of the flower starts growing and it becomes longer than the flower. And then that's indication that a flower has turned into a tomato. If the green parts of a flower like that are still small, and the flower is bigger, that means it's not yet fertilized or it's on its way. But the moment a person sees like that, that the green parts are longer than the tomato, than the flower, that means it's tomato, it's fertilized, and that's that. That's easy way people can tell that and know. But that's something huge, interesting to point out. You know, nuclear physicists, they never even thought about that, to do that. This is now actually, to me in physics and my thinking, this tomato is like sort of like how a hydrogen bomb is made, but one for health. Not one that explodes, but a nitrogen carbon bomb. That's what it would be to me like. Because the nitrogen and the carbon is entangled into a tomato to form a tomato. And that's why it's so cold, because all the cold atoms are sticking together and they are irradiating cold temperature. So right there I can feel the cold coming out of the tomato. And that's because they are entangled to each other. Liquid nitrogen is extremely cold because the atoms are so close to each other, you know, in liquid nitrogen, because it's a liquid. Many liquids are more, atoms are closer to each other than even a solid. Water is more closer, molecules are closer to each other when it's a liquid than when it's ice. That in physics that's known and everything. So all the carbon atoms right there and the nitrogen atoms and the other minerals and everything, they are cold and they are sticking entangled to each other inside the tomato. And that's why it is so cold, because all the temperature in the neutrons of them is entangled to each other, and then it irradiates cold. Because all the neutrons that are extremely cold with dark energy in them, they are all entangled to form a tomato. And then they are irradiating that temperature, all the neutrons in the tomato together. So that's how people can know how well they are doing in their tomatoes and so on. About fertilizing, I didn't really explain that fully, is what I observed when I was doing all those things. With a toothbrush, it's for sure easy and so on. But sometimes people can just go like that, like hit the where the plant is a little bit, and then the flowers will move. And then a person should watch, just like if a flower sort of like sneezes. That's what happens when flowers are fertilized. Sort of, it's somebody sees a tiny little molecules that come out of the flower, pollen. It's sort of like a flower sneezing, and then it's when a person observes it, it's sort of like somebody sneezes, and then the light hits some of the little molecules and bounces off them. So it's sort of like that, and then people know that it's fertilized. And on the dinosaur tree, there is tons of flowers now fertilized. There's like 4 right there. There's like 8 right there, which are turning into fruit. They're not growing as fast as the ones there because it's a lot bigger plant and a lot of the energy goes into the plants. But that's all fertilized right there. That's 7 of them and 2 more flowers. And that's the 8th one flower now curling right there. So that's 2 fertilized, except that one at the end. And right there, there is like also 3 fertilized, 4 actually right there on the dinosaur tree. So it's going very, very well. The dinosaur tree too is gonna give fruit, and tons of them, tons more of them than the other ones, which the plan was a test actually to see how will it cope and so on, because nothing is cut away from it and it's fully working. Right here too is like about 3-4 flowers fertilized right there. The green part is sort of almost bigger than the flower, and one behind it, therefore those are tomatoes now. So even the dinosaur tree, and here as well, is the biggest one on it growing. But the dinosaur tree has tons more energy in it than the other plants, because it is the biggest plant and everything. These are all fertilized here, and that's where the biggest tomato is right there growing. But it's sort of pointy. The other ones are sort of like round, but this one is sort of pointy. But that's how it's growing. So, and these are all fertilized too. They are tomatoes, but they are going step by step. They're all fertilized here. So 6 of them right there. So even the dinosaur tree You know, farmers, they say, oh, no, you gotta cut away the suckers, you gotta cut away this, cut away that. But there, that's evidence that there's tons of tomatoes now growing on the dinosaur tree. And okay, not as fast as that one, but that's a very tiny little difference. And the dinosaur tree, by my estimates, will give like 10 times more tomatoes than this one. That's what the physics is saying and everything. So far the dinosaur tree has 24 tomatoes growing on it that are now fertilized flowers and are really tomatoes. 24 are on the dinosaur tree, and on this one where all the suckers were cut off, not all of them but most of them, there is 28. So this one still has more fertilized tomatoes than the dinosaur tree, 4 more. But the dinosaur tree has flowers like 10 times more on it than that one, because it has 25 suckers. This one has about, let's say, 8 suckers. But it has 28 now tomatoes growing on this plant, and there is like about 7 suckers on it growing. 8, no, exactly 8. So this one has 8 suckers. There is some flowers there and a sucker. That's all suckers. All these things pointing out, that's suckers. All the leaves were cut off and so on. If somebody doesn't know, an easy way to see that is a sucker is right there. That's a leaf right here. That's the main branch, and the one in the middle, that's a sucker. And farmers would usually cut that off simply because to get more energy to go into the fruit and not into the plant. But as people can see, the sucker is the fruit and gives the fruit and so on. This right here on the dinosaur tree, the first fruit, that's on a sucker. The sucker is right there. That's where the biggest on the dinosaur tree is, on that sucker, the biggest tomato so far. So the dinosaur tree has 24 tomatoes now growing, the extremely cold ones with enriched nitrogen in them and so on. But this one has more, but that's 4 more tomatoes. So what, did I cut off all these suckers for like 4 tomatoes? But all the suckers, that's 25 of them on the dinosaur tree, but they'll all give tomatoes by September, is probably what's gonna happen. So that's tons more tomatoes that are gonna come, and one would lose all of that just to get 4 tomatoes more. So potatoes I planted, and update on that. So here are 2 potatoes in this pot. I only put 2 because the potatoes I plant are going to be extremely big and so on. And the root system is all over, growing very fast in this pot and everything. So those are 2 potatoes growing right there. This one is smaller because it's deeper. That one is sort of closer up, so that's why it's like that. But this one is actually even bigger, but most of it is underground, so that's why it's like that, because it's deep underground and everything. So, and those are potatoes that are for cooking. So the French potatoes, there are some good breed supposed to be. Those are the ones for cooking, and here are 4 potatoes that are actually for frying, good for French fries and everything. So that's like the great big realization, you know. Nuclear physicists, they made the bomb, the H bomb and everything. And now some Russians, you know, they enrich some with energy, some fuels and gases, and that's all they're basically doing now. You know, it's finished, the job is finished. It's like they came back from work, you know, and their wives hugged them. You did it, it works, it's great. You know, what was going on in history and everything. And that was it. They made the bomb and they're stuck, basically. They didn't know how to move forward in some things and everything. In the past, but not even in their biggest dreams could they even realize that they too were made through the same physics. And the food they eat, that they could make it like 1,000 times better through that same physics, you know. And that's sort of a shame that people never realized that in the past and everything. But here, like, it's proven, and that's evidence to me. It's like extremely cold. That is the same exact thing. Okay, nuclear physics, that is some hot stuff and totally different way made than tomatoes, of course. But in physics, it is the same exact thing. These are now quantum entangled, enriched carbon atoms, enriched nitrogen atoms, calcium and some things, and so on and so on. But it is basically the same thing as a nuclear weapon. It is because it is entangled matter to each other, just cold matter that's supposed to give life instead of take lives, you know, and everything. And that's like weird when you think about it, you know. The nuclear physicists everywhere, all over the whole world, they couldn't figure that out. That they would come home and go, hey, what's for dinner and everything. But never in their wildest dreams could they even dream that through nuclear physics they could even make the best dinner that ever happened on all of planet Earth. So this is the chili that I started watering with the tuna fish, and I had to replace the staff because it started going high very fast. So tuna fish blended, when it's all foam like that, is extremely good for the plant. But obviously in physics that's obvious, because tuna meat that's in a can is 100% carbon, but highly enriched carbon compared to the land. So tuna fish, just to point out, to say, is extremely good for plants and for fruit. But I started it in these past few days on this one, and actually on this one I just did it once, and it started growing fast and everything. But this one is the one that is doing the best. The suckers on it are growing very good and everything, and it has the flowers first. These have flowers, but they ain't really that fast like that one, but this one has more suckers growing on it. So some plants, you know, they do things the way they do. These don't even have suckers. Or do they have, well, it has one sucker right there I cut off, and one right there, a small one. That's the big one. But the flowers there are starting nicely, and here sorta, but the flowers are still sort of not as good like on this one. So some plants take it easy. This is the worst one. This one has a sucker, a small one right there and there, so they just barely started because I cut off some of its leaves. But the flowers are like not there at all. They're just sitting there and that's it, not even growing that much. But now I'm sort of even these chilies increasing so that they grow faster in here. And this is something to point out right there. That's a hole, sort of like a volcano, because this plant, I know the roots are that big, so I just water right here and the water goes down under. And these parts I leave dry because no roots yet reach that. So that's smart to know where exactly the roots are, in which place, and then to water exactly that part. Because some of this stuff is expensive, you know. Some people might think it's too expensive or anything. Here the whole pot is full of roots. You can see them right there. Right there actually, they can be seen very well. So the roots are even around the pot and going in all directions and everything. So the dinosaur plant has tons and tons of roots, and doing the best from all these plants here, better and everything. The graphene tree as well is growing like extremely well these past weeks. And the graphene tree also, the plan is that it grows like a dinosaur tree. Some leaves are used for experiments and some things, but the graphene tree is, the plan is that it too becomes as big as the dinosaur tree, so that it grows as much as it can naturally and everything. But there people can see still some stuff remains. I didn't water it anymore because there's the water right there, so that means it was too much for it, and then I stopped. And people can see right there
That's actually honey that I watered this plant with like maybe 20 days ago. So that means there was too much honey in the pot from all the watering. But it was all on the bottom because honey travels slowly. Honey is sticky, it sticks to the ground, it sticks to the roots, it sticks everything. But the water still takes it away because it's individual few atoms and so on. But that's what washes it away. So people can then understand that this pot is full of tons of things. Because when a person waters like that with all the eggs, with all the tomatoes and everything, not all of those atoms go into the roots. Many of them stay next to the ground, and then they even enrich the ground with energy and everything. So the whole energy blends in the ground and everything. So if I water it, let's say in 4 or 5 days, I water the dinosaur plant again, well, it has atoms in it that are even the things I used to water it from months ago and everything. So because not all of that stuff goes immediately into the roots, but yes, it will in time and everything and so on. So sometimes it's just okay to pour in water because the land is full of those atoms anyway. So, and you know, that would strike you when you observe like what these farmers are doing, some of them and everything. Some of them have that now, they say it's like a new genius solution. They use fish in farming. They give pebbles to fish, the fish eat it, and then the fish waste goes to the roots of the plant, you know. And they go, oh, the Mayans used to do that, it's such a genius solution and everything, you know. But that tells you how much that's totally out of date and everything. You know, farming hasn't really changed. Farming hasn't really changed for like thousands of years and everything. And why is that? Because they're still using the same ideas that people used thousands of years ago. So that shows how much there is progress everywhere, but just not in farming, you know. And farming is food that gives people life and everything. And then that strikes you like, how come people care more, let's say, about their iPhone than the food that gives energy to them and to their brains, you know. And then you understand how much this physics is so great and so important. But since nobody knew it, I discovered it and everything. So the enrichment of atoms of food and everything. But it shows how much that's like very important and very good. And all these projects are going to be evidence and proof of that and everything. But tells you how much, you know, how stupid those ideas were. Like the Mayans did that because they had no other choice. So they used the waste of fish, you know. People can take the fish and whiz them. And that's 1,000 times better solution than using fish waste. And they feed the fish some crap, pebbles that are some weeds or whatever, which is total crap anyway, when they can just put in a blender those pebbles and that would be that. But none of them think that up. They think, and they explain that like, oh, it's such a genius solution and everything. But it's totally something from 5,000 years ago, which is not such a good idea anyway. So that's now the explanation for deserts. This is where I got from this plant. I got the purple flowers and everything. And I watered it recently, but it was simply too small. And something was going wrong with the plant. It was too small, and I thought these last I would replant and so on. And these flowers, these leaves are from like months ago on this plant, and they were made of cactuses. And now they're just purple and sitting there, even if it wasn't watered for 20 days and so on. The plant's still surviving and everything. I even just thought to forget about it and I don't care. But the plant still survived and everything and so on. On top it's green, but there it's like that. So that is now the desert explanation. The desert explanation is to water the plant with cactuses. cactuses are whizzed in the blender, and the plant, and then the plant is watered with it. Tomato plants, let's say. And then when the fruit comes, to make them that cold and everything, a whole lot of enriched carbon, could be tuna fish, could be eggs and so on, but a whole lot of greens that are enriched and everything from those plants, from those cactuses, then the fruit is watered with them. And that's the desert explanation, like very, 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 very good for the desert, and it'll work. So a person like that can make a tomato plantation in Egypt if he wants, and it'll work. A person can do that outside of Las Vegas, right there, plant tomatoes like that, and they will be enriched, very good, healthy ones, and they will give fruit, and they will live in the hottest summers and everything, and give fruit. Plus, because of the heat then of the desert, those plants will be even bigger and better and everything and so on, because their internal temperature will still be cold and made out of cactuses and all the cold stuff, and in general that it's watered with cactuses and greens. Greens originally have nitrogen in them, of course. Everybody knows that in physics. The greens of plants have a lot of nitrogen in them. A plant takes water, hydrogen turns into wood, and the oxygen turns into nitrogen. Because oxygen too, that's in water and that we breathe, oxygen is like two nitrogen atoms by particles, but it is still a lot of cold matter. It is like 85 something percent cold matter, so good nitrogen comes from it. Yes, I have in the plants enriched nitrogen, so that's why they are now, the tomatoes are extremely cold, but anybody can do that if they follow those instructions easily. So they just take greens like this in the blender, blend it with water, and then water in the desert a plant with that, and then the plants will give fruit, any fruit they want in the desert. In the future, I plan to make even coffee plantations here in Europe. I plan in the Balkans. I plan to even make banana plantations, even if people believe that in Europe that's not possible because they do not grow here, but still I'm gonna do it, I plan, because I know a way to do that as well and so on. But those are the simple instructions. A person waters a plant with cactuses when cactuses are in the blender turned into a liquid, and then waters plants with that, and then when fruit comes they water with eggs, with tuna fish, good stuff, but also a lot of greens that have a lot of enriched nitrogen in them, and then the fruit's internal temperature will be very cold, and it will live in the desert and grow and give fruit easily, like as easy as pie, you know. Which is like a simple explanation, but a whole video I will do on that, to do desert plants. I just needed more information and more research, so to do that like in a good way and everything. And today I watered this plant, and I can show people that's what remains right there. That's now a lot of tuna fish, a lot of eggs, a lot of things right there. But this is what the blender didn't really blend into a liquid that much. So some of it remains there, but I could take this and re-blend it again. But I just pour a lot of water over this, and it sits there, it goes dry. When atoms are individual atoms, they do not really stink or anything and so on. That's just when they are big pieces, they go bad and so on. But this, if it was outside, it'd be okay. But this stuff now I should take and re-blend it again and then water again next time, because a lot of these parts remain. So then if that happens to somebody, then you just need to do it longer. Let's say 10 minutes you leave the blender on, and then even all this stuff will turn into a liquid and so on. So that's the simple and easy desert explanation how to make any types of fruits and plants and vegetables in the desert and so on. The plant is first of all from the time that it's a seed watered with greens that grow in the desert and with cactuses and so on. But there will be in the future special videos and special plants that I have thought up that will be those types of plants. So special for the desert and some special ones for the cold places like in the earlier videos that I mentioned, Canada, Russia, north of Europe and so on. So that's sort of what's new. So now I replanted these into these cups that are see-through first. So as the roots grow and everything, I can see the progress of how it's going. I can even see the water, how deep it goes when I water it and everything. So if people can find see-through pots and everything, that's a huge better idea to have than these where you cannot see what's going on inside and everything. And now I replanted these here, and they will be what I plan with them is they're all going to be different things. One is even going to be a glow-in-the-dark plant that I plan to test out and then make some of them during the summer. And I'm going to plant them all around my hotel to be like for sightseeing, something similar to Avatar movie. So when people come over, there'll be plants around that glow in the dark and everything. I plan to do that around my hotel, but I have just started that idea now, and I'm gonna start to work on it. Probably that one there, although that one is the breed, the same one as of the dinosaur tree. So that's one that can grow very big and everything and so on. So these are cherries. So originally cherry plants don't really grow that tall. Neither do habaneros, but I'm gonna make them special, some huge big ones anyways. Gonna try with them. But this one is the one that really grows non-stop and grows a lot and everything. But if I make it glow in the dark, it can still give fruit that is edible. Just the fruit should not be watered with that stuff, of course. But people would probably find that strange, you know. It's a glow-in-the-dark plant, but you eat from it and everything. So these days I cut off some of the leaves. It was some like black spots that I thought that was from the meat that I used, but it's actually not. And so that it doesn't spread on the plant, I cut off some of them from the plant and everything, from multiple plants. And that's what that is right there. Now people that garden and everything and farmers, they call that a disease, and that's not really a disease or anything. To them this turns yellow and dry. On my plants it cannot turn yellow and dry because my plants are made out of bigger, richer atoms, so they do not turn yellow and die. Only some, very rarely, flowers do, but this is how that happens to my plants. This actually happens because of evaporation from the ground. Whatever you pour in the ground, water or anything, such a chemical thing happens that outgoing masses, that quantum gravity of Earth picks atoms up and carries them up and carries them into the flowers, into the leaves, sorry, and then they become too moist, the ones near the bottom. So then I cut them off there and there, and on the dinosaur tree I cut off just two of them that were dark. On the dinosaur tree there were only two sets of leaves that I cut off that had these spots, but I thought so that it doesn't spread throughout the whole plant, I cut them off to prevent that from spreading. But then I realized this is not really about any disease, and this is not even about anything unnatural like a disease. This is actually about the what you make the plant out of. See, the dinosaur tree doesn't have any of it on it. It was only two leaves that had these spots, and I cut them off. And there people can see, as I lifted, the spots right there. But to other farmers, this would be yellow and a dead leaf. But my leaves, since they're made out of enriched atoms, when this happens, that can't really happen. There's a little spot right there, and there's like a dot. There people can see a dot, and that's a dry dot right there, next to that black stuff. That's a dot where the leaves are dry, where the disease really, they would say, took hold. But the disease doesn't, that's not any disease or anything. Those are just atoms that cannot hold moisture that well. And that's all that happens. And then when there's too much evaporation from the ground, it's too much for them, and such chemistry happens that they turn dry. See, so that's all that happened to my plant for like months and months that the plants were growing. But because of this dark spot, I thought I'll just remove these leaves and use them for whizzing and everything. But that's not any disease. And this dry spot right there that people see, that's actually the ground. That's not the enriched atoms that I used. That's actually the ground that it picked up when it was watered, and that's why it has that spot right there. But as people can tell, even if they all change color right there, very few leaves have those spots. They're like very, very tiny. People can see like little dots, like right there. That's because my plants are mostly made out of enriched atoms that can hold out even in that moisture that's evaporating and anything. To other people, this would be totally yellow and dry and dead leaves and everything. Sort of like that one right there. There, it would be like that, so to speak. But even that one, that's what they call a disease in farming. Disease of a plant. But that's not any disease. That's just the atoms don't really hold well moisture in there and so on. Or it's overwatered or something like that. But the whole point is that these are dry, very dry parts of the leaf that cannot really hold moisture that well. And this is the ground. Through chemistry and quantum realm, this is the ground that my plants picked up. Because when I water, every time I water with water from the blender. So the water already has all the rich atoms in it, and that's what goes into the roots. So I look that not that much ground is picked up, although this ground, the rich atoms have been going through it for a long time. So that even enriches the ground, because all the energy from all the eggs and everything and the cactuses and the tunas, it touches the ground as well and enriches the ground as well. So that energy from all those atoms. So even this ground there is enriched compared to other grounds. But these are old leaves that were at the bottom. So those are from a long time ago, when the plant was younger and smaller and everything. So, but these are all the ones that had those spots. And I thought I'll just cut them off and whiz them anyway, because I do whizzing anyway, because these are enriched atoms, and once they turn into the plant again, they'll be enriched again, and again. And all these atoms will then be enriched again, and again, and they'll get greener and greener and greener. There's one spot that sort of seems dry and everything. So there people can see, when you make plants this way, through enriched atoms and good atoms, then even your plant is resistant to these types of diseases. Only like a little bit there on the edges does the plant turn dry, and so on, the leaves and everything. But people can know, if they have those types of diseases spreading through their flowers where they become all dry and everything. Yeah, that does spread throughout the plant, so I cut this off so that it doesn't. But if you water plants with enriched things, here it can very well be seen what happens to mine. My flowers, they just have these spots. I thought it was because of the meat, but then I realized that it isn't. But this looks to me like it's sort of too greasy. So it could be that it is meat. those spots right there, the meats that I used and everything. But as you can tell, even if that dry things start, if you water plants with enriched things, they will not go bad. They'll just change color, but they will not go bad. Only at these ends did it go bad right there and everything. But these leaves could have lived on and everything. But these will not pick up sunlight that well and so on, these dark spots and everything. And so to prevent this, I just cut them off and everything. And they can be used in whizzing. But people can see there's a hole right there. So where the leaf really went dry. And this is the atoms of the ground that when I water the plant, it picked up right there. And those are the least enriched ones, and that's why it went dry like that quickly and so on. But this leaf still has moisture in it and it's still good and everything. But this looked sort of greasy to me, so I thought that was actually the meat that I watered the plant with. But it turns out it actually, well, maybe it is, but maybe it isn't. Maybe it's that just that spreads throughout the plant. So I cut it off right there from the bottom parts so that plants have more airflow. And then people say you need airflow for tomato plants. That's not really about airflow. That's about evaporation that comes out from where you water the plant. See, when you water a plant, right there are outgoing masses. Quantum gravity of planet Earth that is coming out of planet Earth and is going into space, going towards the moon, Mars, and everything, which is a force that picks up quantum things. And every time you water things, that's how steam goes up, that's how smoke goes up, so on and so on. But every time you water a plant, then so does from it quantum gravity pick up things, and they go up, and they go up and hit the leaves non-stop, and then those so-called diseases happen. This one here is very nice and green, close to the ground, but it's very nice and green and everything. And the suckers I still left on, and they are doing very well anyways, because they'll give fruit, so I'm not gonna cut them off. But that's actually reality, what is going on. That's just evaporation coming from the ground and hitting the leaves. And then they start turning dry and so on and so on. And farmers call that a disease. That's not really a disease. It's not any type of disease. That's just too much moisture and a change of temperature, so to speak, sort of a swampy environment. And for tomato plants, that's not really good. But the easy way to do that, to prevent that, you just cover the ground. You water the plant and you cover this with some type of foil, like a plastic foil, like a plastic bag or something, and then none of that will hit the flowers. It will hit the leaves and you'll never have those diseases anyway. That's the easy, simple way, because quantum gravity picks things up and they go up. But if they hit right here into some tight plastic, like some tight, very tight plastic bag, strong, then they cannot go through it. They'll never hit the leaves, and you solve that problem very, very easily. And then you don't even have to cut off suckers in these bottom parts anyway. That's just what people do. That's just what some people do because they think that's a disease or something. But that's not any disease or anything. That's just change of temperature and change of moisture for the leaves that are down there. But even if you cut off these bottom leaves, that's okay. They're old and you don't really need that many leaves. I mean, my plants are about 3 meters big, so I cut off the leaves so that more energy would go into the suckers actually. Right there on this plant, all the suckers are there except one that I cut off. And I cut off some leaves so that they stop growing, so that tons more energy go into the suckers where the fruit is starting and everything. So you can cut off leaves anyways, but in the summertime you will need leaves so that the plant picks up photons and then makes special vitamins and special tastes. Sort of tastes come from that as well, you know, from the photons that the leaves pick up. The tree is actually a quantum realm factory, you could say. more advanced than any NASA computer or any NASA engineer can even imagine. If you see it through the quantum realm and the beautiful physics of it, water that comes in turns into hydrogen, it makes the wood, turns into nitrogen, that makes the leaves and the fruit and everything. And the carbon and the nitrogen is mostly what goes into the fruit and what we eat. And many of those parts come from breaking down water. When we break water down, we break it into oxygen and hydrogen. We just let a current go through a pool of water, and then the oxygen and the hydrogen separate, and we get like a fuel of hydrogen, like that way. Sort of, that's how it's done in physics. But the plant goes even further than that. It breaks down water into hydrogen and oxygen, and then it breaks down oxygen into nitrogen in one oxygen atom. So that too is like a big realization in new physics, something great and very revolutionary. Some water molecules, the plant and evidence is showing, because it's making nitrogen, some water molecules are actually one nitrogen atom and 3 hydrogen atoms. Some water molecules are actually that as well, because all the grains and all the grains outside too, most of that is nitrogen. Everybody knows that in physics today. Most of the grains you see around planet Earth, that's in big part nitrogen. And where would that nitrogen come from? From water. So that would be like a new element also to point out in physics. That is something also great and revolutionary to know. Very good would be that some water molecules are actually one nitrogen atom and 3 hydrogen atoms. But a nitrogen atom and an oxygen molecule and an oxygen atom, they're almost the same. All that oxygen is nitrogen with what? One hydrogen. Like I pointed out in earlier shows, oxygen is about 80% dark matter, which is nitrogen, and sort of like 15-20% is hot matter. That's oxygen. That's an oxygen atom. But you take away those 20% of hot matter, then you got the total nitrogen, of course, you know. So something also very beautiful to know in physics, and also very beautiful to know in for plants and everything, because all the greens and all the tomatoes and why they are so cold and everything is because of enriched. But here in this tomato is like several times, 3-4 times enriched nitrogen in it right there. So that's why of course it's so cold and everything. See, I touch it like that and it's like I'm taking something out from a fridge, you know. It's sort of like that. And that will protect it from pests, protect it from change of temperature, protect it if it becomes too hot, and so on and so on. So that is also huge and very good to know. Enriched nitrogen is even a lot better, and so on. But that's all actually oxygen is. In reality, when you observe it, oxygen would be one nitrogen atom with one hydrogen. That's actually what oxygen is, because oxygen, liquid oxygen is like minus 280 maybe, but liquid nitrogen is minus 300, sorry. And that's why oxygen is that little bit less cold when it's a liquid, because it has some hydrogen in it, and hydrogen is hot, of course, so people can easily understand that. So one takes away the hydrogen from the oxygen and he gets liquid nitrogen then, which is totally cold, minus 300. But this nitrogen right here, which is enriched 3 times, 4 times, in the future I plan those types of experiments. If I made liquid nitrogen out of such tomatoes that are specially made for that purpose, then liquid nitrogen would be like minus maybe 500, minus 700, and so on and so on. So that's the beauty of things, to understand things in a new way. So all oxygen is just a nitrogen atom and one hydrogen atom to it. And that's also what the plant does. The plant takes hydrogen, turns it into wood. So that's like right there. That's the in the middle part right there, that's wood. There people can see it's dry. But how it works, on the surface it's wood, but on the inside it's actually other things. On the surface it's wood to protect its inside, but on the inside it's cold matter and everything, where the atoms flow through the plant and go to all of its parts. But that's where the hydrogen go, to the surface of the wood to protect the wood from the outside and to make it tougher and stronger and so on. So that's what the hydrogen is for wood, and that's why wood burns, because it's hydrogen. But then water also, the plant also takes water molecules, but breaks them apart even further. It takes 3 hydrogen atoms from them, and it takes nitrogen from water. And then that's how you get the greens, and that's how you get the fruit and everything. Then also it takes carbon atoms and turns that into fruit and the wood and everything, and so on and so on. So I'm back in the wild. The last time I was there, it was a little bit windy, and the view wasn't that well, so I left. I thought to explain that a lot better, but I couldn't that day. So I came today. It's a little bit raining, but it's okay, you know. Like the Postman movie says, through rain and through snow we go. It's a cool movie. So this is now something that has, first I saw as something nice to point out. This is now something I used in my plants earlier, because I saw these sticks. I don't know what it's called in English, but you can see right there what it is. It's something local. It's all over here where I live in the coast of Montenegro. It's all over the place. It grows. Nobody plants it, but it grows like crazy everywhere. So it's like a straw thing, but it has some type of strong greens. It's like tight, strong, and now it has given these flowers. So now it's blooming and everything. During the winter it didn't, but I took it because these greens that you see right there, they grow even in summer and even in winter, cold or hot or whatever. They grow like crazy all the time. But during the spring, like now, it is giving fruit and everything. I mean, it's giving flowers. These are not fruits, but are some nice flowers that are sort of look rich and look very, very nice and everything. So these flowers, if you find some like these that are these pretty color, very, very nice, they're also something nice you can take sort of for some time. When your plants are giving flowers, then you can take flowers like this and everything. But this green right here is something that I used when the plants were very small, the dinosaur tree and everything. When they were very little, I would take some of these greens, and the purple things that I showed, the purple leaf that I showed today, some of that purple is actually from this stuff too. So this is similar to a cactus, but it's not really a cactus. It's more like a different thing and everything. So that's one thing to point out. Now the grass on the bottom, this is the least enriched stuff. And you would find this crazy to believe, but this least enriched stuff, cows eat that. and then they make milk, and we're made out of this stuff. The least enriched stuff on the ground. So you'd be surprised, but that's what cows eat, grass from the ground, which is the least enriched atoms like on planet Earth. Rain falls and then goes into the mud, and then out of rain and mud, grass is grown. Grass, I think, are some subatomic seeds that nobody can even see with the naked eye, but they're all over planet Earth, probably, or something like that. All these flowers have those probably subatomic seeds and things in them, and they just fall there, and then they come back, and so on for thousands of years. But that's like interesting to point out. So these least enriched atoms cows eat, but okay, they turn it into milk. Milk is a very strong enrichment, and then we drink that milk as children, and most of our bodies are made out of that, out of other things as well, but this stuff actually. But okay, nobody knew this physics before and everything, you know, so that's probably because of that. But you know, let's say if we make some enriched grass, some totally great grass, well, then cows would be making milk out of that, you know. And cows go to the fields where there is fruit, vegetables and everything to eat that, but the farmers don't let them, you know, because they don't even know this physics and everything. But there's all types of different types of grasses. See right there, this is now something tighter, stronger, this type of grass. And there you can immediately tell by the color and the density that it's something tighter and stronger. Yes, it's made from the same stuff, the ground and rain, but you can tell it's tighter and stronger, like that. See, you can take it in your hand then and see. And I can tell it's more moist inside and tougher than the ordinary grass. So that's how you can tell if you're in a forest looking for good atoms for your plants, which are free and everything, and this stuff on top, although this is just flowers, that's then not so bad. But you look for something that's tight. The first thing with the yellow flowers I showed, that's actually very good stuff. But this is what I wanted to show. This is something like a Christmas tree. It's sort of not a Christmas tree, but the same type that grows during the winter and during the summer and everything. Plus, this has got some berries on it. And these are wild berries right there. So this is something that gives even fruit. But these berries nobody eats. These are some wild berries and something, but they are fruit. So if you find those types of things in the forest, this is good stuff, very enriched stuff in a forest, because it's forest berries. And forest berries are a lot better than even the farmers' berries that they make and everything, because it's made from wild stuff and everything. And this tree's got that all over the place. So this is the stuff, sort of like this stuff. You can see what it is. Canada is full of trees that have this type of greens. So these are the greens that grow even in -40, -50 in Canada and everywhere. And some of the habanero chilies, because they're very good for all types of different things to be made out of, I'm gonna make out of this stuff. Stuff like right there. And this is brand new. I can tell by the color it's not that old, so it's brand new. The atoms are fresh and full of energy and everything, so it's not spent and so on. There's some of those berries growing and so on, and they could have something very good in them as well for plants, especially because it's these types of things that grow. But it too gives fruit in the spring, like now in May and so on. But all those trees there, you see, and that way, that's all stuff. That's all the types of greens that grow during the winter and during the summer and everything. So there's tons of those things all over, everywhere on Earth, except in deserts and everything. But that is also smart to point out, you know. If somebody wants to make, let's say, plants in the desert, well, you can get this stuff as well. Because this is atoms, neutrons and protons, but made out of extremely cold energy enriched. It is the ground and water, but the green you see right there, that's the enrichment of neutrons that gives it that energy that it can be green in -40, -50 and everything. So it's a strong cold enrichment. That's like the physics explanation that's important. So even if you want to make plants in the desert, you take these and you whiz them in a blender and then you water plants with that. And plus this stuff is all over, free even, and so on. You can find it in many places. And then you just whiz that and you water plants even in deserts, and then they'll grow nicely because these are extremely cold, enriched to neutrons, and probably nitrogen, cold, very extremely cold, that can live nice in hot temperature and in cold temperature. So some of the habanero chilies, and some of them I'm planning for them to live throughout the whole winter here, and I'm gonna water them with this stuff. Not just this stuff, there'll be other stuff, but this will be one of the big ingredients and so on. And plus it's free, so. But cactus is also another big important part and so on. Okay, this is just not that much a good idea because all these are pointy spikes. And if you touch them, they cut through your skin. So I just tried, and it doesn't seem like a nice thing. But I can cut off the branch. I just didn't bring equipment for that. Didn't plan on that, but that's okay. But I got a berry right there. And as far as I can figure it out, the berry, this is sort of like land. See, this is not even a fruit. This is more like a type of ground wood, so to speak. The berry has no moisture in it or anything because it's not watered with good stuff. It's not in an enriched forest. If it was, this would be some tasty fruit for some special animal, probably. But here it's just like that, it's just like some type of wood thing inside the berry. But that's simply because there's not enough energy in this place for this tree to produce a nice juicy fruit that's edible and everything. But it can be turned into something like that very easily if it was watered with good stuff. But this tells me this is very good land fertilizer. So if I took these berries and it would be a put it in a blender, this would be extremely good for making the hydrogen parts of the plants. So the wood parts of the plants. It would enrich them and go there very well and give very strong wood and everything. Because that's what it looks like. But this is simply because it's made just out of rain and ground. And that's why the berry is like this. It has no juice, no vitamins and stuff in it and everything. But this is also a good idea to be turned into some type of fertilizer for just the ground and everything. But that also tells you that sometimes I think about if I had, let's say, the fuel from the space shuttle. And I know how to make that. That's not that hard to make. It's just liquid hydrogen and some stuff. That's not that hard to make. But if I took a tree like this and I would water it with liquid hydrogen, then I could even make some wood that's so strongly hot and everything, it could even turn into a bomb and something. And that also is a cool business and everything. A cool idea about that stuff and everything, to water a tree, but that would have to be a tree, not a plant, with liquid hydrogen. So now I opened it further and I saw inside it has some like sticky honey. It's sort of like if you would you know, like stuff that comes out of a tree, the sticky like flowy stuff, but it turns hard when it's like too hot and everything. So it has that stuff in these berries and everything, like some sticky stuff, but it's similar to honey, you could say, but a totally different smell. That would be like some winter honey or something. And what would be the use for this? Then I asked myself. But that sticky inside honey is enriched atoms, see. So even right there, something totally useless. This is just a tree for its looks, probably nobody even picks these berries. But it has some enriched atoms in it, similar to honey right there. See, so even this berry that I thought is totally woody, on the inside it has that stuff, and it probably has the seed of the tree and everything. Now this too is something interesting to point out. This right here is called copriva. That's like the stuff that is also pointy. If you touch it, it you know, hurt your skin and everything. But that's sort of the design of it, so that the animals stay away from it and everything. It has flowers too and stuff on it. The design of it is so that the animals stay away from it, and that's how you can tell when something is. That's sort of like a local cactus. Cactuses grow in the desert, but in Europe and places, this is the like substitute for, this is like our cactuses, European ones or something like that, but they're totally different type and everything. And this here is also, I think, extremely well for good for making winter strong atoms that can hold out in the winter and everything and so on. And there's just some goat droppings right there. Although that's all made out of weeds, people can see, and grass and stuff and leaves. But you know, the farmers all over the world, basically, this is what they make vegetables out of. All the vegetables you eat on a plate, it's made out of this stuff. You know, number one, it's free, so probably that's why they do it. Number two, that's how it was done for thousands of years. So compare that to making your vegetables out of honey, out of tuna fish, out of very rich and good atoms of eggs and so on, you know. So there's a huge difference and everything. And these are atoms that are breaking apart, that have, their temperature was changed because they were inside the stomach of an animal, and then they started to waste. The moment atoms and food come into the stomach, they start to give off energy. And that's even evidence of what I've been saying today in today's show. That's why waste is like that. Subatomic particles are coming out of it and it stinks, you know. I mean, sorry, some people maybe don't like to hear that stuff, but that's to explain the physics of it and everything. And that's why that happens, you know. It stinks because there is atoms and subatomic particles coming out of the waste. That's because its temperature and chemistry was changed, and it starts to give energy. And the same thing happens in blood. Just some parts go into the waste, some parts go into the blood, and so on. And mostly liquids actually go into the blood and so on, milk and stuff. But that explains that whole story. As soon as the temperature and the chemistry of food is changed, it starts to give off energy. That's why waste stinks. And farmers would take this stuff that wastes away for months and months, and they make the vegetables out of that. But that's sort of like the old way of doing it. And what I'm explaining is like a million times better, million times healthier way to do it and everything. So I'm gonna take some of these today, and I'm gonna show later what to do with them and everything and so on. So this is not a cactus, of course, but it's very similar to it and everything. And the flowers on it are very rich and good looking and everything. Also, what people do in many places and forests and everything, they take wood like this old and they burn it. They burn it, they turn it into ash, and then they think that's very good for the land. And yeah, that is good for the land, because ash is 100% cold dark matter. And that's the only reason why ash is good, because all the hot matter goes away, and then all the cold nitrogen and neutrons are there, and that's very good for the plant. That's what you get in ash: carbon, nitrogen, cold neutrons that all the heat has left them while it was burning and everything. So if somebody has this stuff around, that's not a bad idea. But you can enrich wood, what I just mentioned, but not with hydrogen, of course. Hydrogen will just turn into fire, and that's that. You can enrich wood with some enriched, let's say, carbon. Well, tuna fish maybe is too expensive, but tuna fish is extremely good for that. eggs are very good for that, to make some enriched wood. That's extremely good for making enriched wood and everything. But wood needs hydrogen to be wood, so that is correct. The carbon atoms, they entangle with the hydrogen and everything. And this is a very nice place here where I go. It's near my hotel where I live, and here I plan in September to buy land and to open up big laboratories where it's going to be 20 meters tall. Land here is not that expensive. It's not that close to the sea, especially there in the mountains. The land is like cheap, very cheap, and I plan to buy sort of 2,000-3,000 square meters and open up like the best farm laboratories possible, and then all kinds of stuff is gonna be there. I plan like tomato plants, 20-meter tall ones to make, and so on and so on. And in September I plan to buy land somewhere here. Up on that hill is also a good place, gets a lot of sunlight on top and everything, and then to open that up in September. So this is what I'm gonna get. This is like people can tell also a tree that grows, its greens grow during the winter and during the summer, and is exactly like the stuff in Canada and so on. There it was too pointy, cactuses and all that stuff, you touch it, it cuts your skin like in 50 ways and so on. But all these trees are that, you know. And that's basically free. But this is very good green atoms right there that will turn the plant into that cold version that I'm gonna do. And I'm gonna do a few habanero chilies on that, and some tomatoes that I plan to leave outside throughout the whole winter. And I'm gonna make it out of this stuff, but some other stuff I'll show that later, and so on. What else? Many different combination of many things. Some are gonna be cactuses, of course, too, as well. So, and this stuff too, this is also the type of plant, the type of tree that grows in Canada, in Russia during the winter, -40, -50 degrees. And these greens are those greens. So okay, so now I thought to show people what the big deal is about these greens that can grow during the winter and everything. These are like the ones from the tree people saw that I got, and these are like the ones that grow in Canada and everything. And it seems it's not really just about it being a nitrogen a lot. It's actually about it being hydrogen a lot, entangled tightly to be like to withstand the cold and everything. So actually what I said before was, it seems a lot more correct, because I thought to now try that on these and see how they burn. And these are actually mini explosions. That means it has tightly entangled hydrogen in it a lot, it seems. So people can see right there as it burns, it has these mini like pops. It's going that way, that way, that way. That means when the fire hits the hydrogen, it's like a mini explosion going on, and it's going boom, boom, boom. It pushes the fire one way or the other. So people can see like these mini pops that it's making, and that fire goes this way, that way, like poo, poo. So, but anytime anybody's in a forest, you can do this with a lighter and see. Of course, there is ash, very white ash, people can see right there. That's the dark matter, of course. That's the carbon, the nitrogen, and so on. But it is entangled with a lot of it seems very tight and strong hydrogen that is entangled to each other very tightly, and so on. So it seems that it's a blend, but why it lives during the winter is because it has tightly entangled hydrogen that give it heat. So even if it's cold in Canada, very much, these types of greens have a lot of hydrogen tightly entangled to each other. So it gives like these mini explosions. Like that, people can see it moves the fire one way or the other. So that's the cool thing about it. But anytime somebody's in a forest, he can do this with a lighter, with any type of these greens, and see what's in. The stuff that's burning right there, when you see that heat, that's the hydrogen right there. But the hydrogen goes away. If we want to get just the dark matter out of it, you just burn it and you take the ash then. But the ash is totally atoms that... But the ash is a lot better for living longer, but the hydrogen has its uses in a plant because it'll make it live. It'll make it live during the winter very, very well. But when we make the fruits, then it's supposed to be all the coldest dark matter, so the ash and everything. But there are better greens that don't really need to be burned, that are totally like that. Okay, so now I got the cactus. Now you're all probably thinking, why would I use cactus? Cactus is very cold stuff, and it's very, very good to make plants in the desert out of it, like I pointed out in earlier shows. And yeah, that's all correct. Cactus is supposed to be used. It's extremely good to make plants in the desert, to give fruit and live good and have moisture and everything. Cactus is perfect for that. But it's also very, very good, but in small amounts, to be in the winter plants as well. Because the first thing that kills a winter plant is that it goes dry. The cold freezes or dries the moisture in the plant. And then it leaves, it's gone, and the plant goes dry and dies. So another thing that kills, let's say, tomatoes in a very cold environment is that the leaves go dry and have no moisture in it. And cactus is perfect for having a defense against that, because the atoms are very, very huge and hold moisture very, very well. The cactus is extremely good for making sure that the plant has moisture. But we're not going to use too much of it because the cactus is cold stuff. But now, because it's summertime coming, I'm going to use cactus and to have that moisture dependency in it. But when September comes, it's going to be 100% in the plant, this nitrogen stuff. But in September will be, this hydrogen stuff, to make it live out through the winter. Because by September it will give fruit, and fruit will be made out of cold stuff anyway. But then when winter comes, and the test is going to be how to make that big plant live even in the winter, and when it's very, very cold, then it's going to be mostly, and when it's not giving fruit, just the hydrogen stuff. So the other two greens I showed, tons of them will go into the plant. But here I thought to show people the cactus this is mine that I grow, of course, and everything. But I thought to show it has a spike right there. Now the spike is just wood. This is ordinary wood on a cactus. And this is the spike that sort of protects it from animals that they don't eat it, and so on and so on, and from people even. People don't touch cactuses because they know they're gonna cut themselves and everything. So some plants have these like design that protects them from animals. Animals know not to come near it, and that's that. So those types of plants have some like they have a reason why they are protected like that. So maybe from animals and so on and so on. But to show that the cactus doesn't even burn at all. See, the cactus is greens, but it cannot burn at all. You see, the cactus, he's fine. You can go like that for like minutes and minutes. There is some black smoke coming out, but there's nothing burning. That's because there's no hydrogen in here. Or even if it was, I do water it with water. This is not from a desert. This is my cactus. I water it with mineral water to give it minerals and very, very good stuff. But the design of a cactus is to be extremely cold matter, and that's evidence right there. And the fruit on those winter plants will make out of cactuses, because that means it can hold the moisture in, it will not freeze, and it'll be perfect for that, and it'll be extremely, extremely rich and good then to eat and everything. Because the cactus atoms, through physics, I have understood, maybe they're extremely good even to eat, to make like a juice out of it. But if they don't have some chemicals in them, I have to do research on that then to see, are cactuses edible and so on and so on. Probably they are. But these cactus atoms, number one, they're extremely cold matter. As you just saw, it cannot even burn. That means it's nitrogen, carbon, extremely rich. Number two, it has moisture in it for years and years without even being watered. In a desert, that means it's full of moisture. That means the atoms are extremely big and extremely full of water and energy in them. So when cactus has atoms go into blood, that could be even something very good thing. But I even have enriched cactus atoms, like I just showed the pink flower and everything. The pink leaf that I cut away a month ago, these are now cactus atoms, but they are a tomato plant and they are enriched. That's why it's purple like that. The cactus is green, this is purple, because these are enriched cactus atoms. They're not ordinary cactus atoms. But still, even if they are a tomato plant, this still has moisture in it. Even if I cut this away a month ago, it's still not dry and has moisture in it. I can feel it when I touch it. So that's the great thing about the physics. See? So this and this are the same atoms, but they can change into huge, huge new things. And I have a lot more of these leaves that are still living on plants and everything. So, but that's to show the cactus. But as one can see by the color, very simply, the spike right there, well, that's just wood. That's hydrogen, and that comes from water, and that's carbon. So obviously that's wood and everything. But that's what I showed earlier. The little tiny hydrogen in those greens goes like pop, because it's hydrogen tightly sticking to each other. See, and that same thing is the hydrogen bomb. Just the hydrogen bomb it's not sticking to carbon, it's sticking to uranium. That's the hard part and the big explosive part. Hydrogen is always hydrogen, and there's of course tons more hydrogen in that than in that. But even in a plant, like I just showed, hydrogen is what it is. It's doing the same thing here as it's doing in a nuclear bomb. It has those little pops when it blows. You just heard it right there. And that's hydrogen right there that people see burning. That's hydrogen. So when you see a nuclear bomb, that's the same stuff burning. Just there it's a lot more of it and entangled to some other stuff. Here it's entangled to cold neutrons and to carbon, which is very, very cold. So here it can't really be that explosive. But uranium is like this heavyweight supersize of, you know, hot explosive stuff. And then not to go into the details, of course, but people understand the physics and everything. So to make winter plants, tomatoes, any type of vegetable, one waters the plants with this kind of things. But any trees you find that their greens live during the winter, especially in cold places, that's this types of hydrogen in them sticking together tightly and everything. Most likely that's that. And that solves easily that problem. But never water fruit with this stuff. Because too much hydrogen, the fruit anyway has hydrogen in it, in the seeds especially and so on. That's where the genes and the DNA is of the plant. And the seeds burn, everybody knows that. When you burn them, they burn sort of like wood because they have, but that's where most of the hydrogen goes, into the seeds and so on. But the fruit itself, the whole red part of a tomato, that's cold stuff. Hydrogen, nitrogen, carbon, and so on and so on. And that's what gives long life and youth. Hydrogen, no. So the plant will make out of hydrogen these types of things, but the fruit will still do something else in later shows, which will be explained and everything. And that's very interesting to point out. So to do these, so people in Canada, Russia, and so on can now easily understand. This has got tightly entangled hydrogen. So even this is blended in a blender, that hydrogen tightly is still sticking to the carbon, to the nitrogen and so on, and that's how it goes. Because the hydrogen isn't gonna break apart in blending, but the point is that it's a liquid and that goes that way into the root. So now atoms from this, it'll be molecules going into the root. So the nitrogen that comes from this that goes into the roots, it'll have like 10, 20, maybe who knows how many, but a lot of hydrogen sticking to it tightly, the way it is designed to be in these greens. And then the internal temperature of that plant will be very, 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 very hot, and it'll survive in the winter and give tomatoes and fruits and so on. So that's easily understood through nuclear physics. Like the hydrogen bomb, we would make a hydrogen plant. That's extremely hot on the inside, but it is, even if outside is -40, -50, and so on. And I got a tomato here to show the seeds. So right there, the seeds that are there, this is some big cherry one. This is a cherry tomato, but some big one, supersized version, some nice one also. And there are the seeds. And now, as people can see, the seeds look similar to wood. And that is because it's carbon, but it's a lot of hydrogen. And in the seed, little seed right there, is all the DNA and genes of the whole plant. And DNA, people know DNA strands are made out of hydrogen, of course. And these seeds burn just like these greens, like I showed, and so on. So the seeds are woody and tough like that because they are carrying information. So, and a liquid is not really good for that. It needs to be solid matter and so on, and it has tons of hydrogen in it. Because out of hydrogen, DNA strands are made. People know that, of course. Even human DNA is made out of the same things. And that's how people pass on genes and so on and so on. And that decides people's appearance, height, weight, and so on, of course, as well. Amongst other things, and so on. But that is very nice to point out also about this. But when we make winter tomatoes like this, it will be made and it will survive the winter very, very easily. But it will not be made out of hydrogen, because if it was made out of hydrogen, sure, these types of greens, it will survive and everything, but it will not be that healthy. And so on, because the hydrogen is what, too much hydrogen in blood, well, that's what makes people grow old faster then, and so on. But if it's nitrogen and cactus things, then that's what makes people grow, be young longer, and so on and so on. So the difference between cold matter and dark matter is the important part, and so on. But there are explanations. Some meats, some types of meats, some types of cactuses, and so on, fruit can be made out of them during the winter, and they'll survive the winter -40, -50 easily, and so on. But some more rich stuff, not hydrogen. There are other things that can survive the winter, of course, as well, not just hydrogen. But in future shows, that will be explained and everything. But that is very interesting to point out about the hydrogen. See, the hydrogen from water that one waters a plant with, that's what its seed is made out of, right there, the woody part, right there. And then that seed in the quantum realm is million, trillion strands of DNA genes, because the whole design of a plant, that's like meters tall, the whole design of the leaves, of the tomatoes, of everything, it fits into that one tiny little seed. So to us, the closest thing to that would be like a CD player, like a CD actually, or like a USB, you know, a USB device. Well, that's what a CD is actually. Just it's carrying quantum realm DNA information, and well, our information is also some little tiny bits that fit inside a USB or a CD or so on. So sort of, you know, in physics we are sort of following and doing the same that nature is doing, just this is design made by God. So this is like, see, we do not have a USB device this small, of course. Ours are a lot bigger still, but that shows, you know, how nature, you know, is sort of, when you see it through physics and science, you see how great and glorious it is, you know, because it's basically the same thing. It carries information. Just here is tons of information, even about the quantum realm and everything. The whole plant is a quantum realm machine that breaks apart water molecules, turns one atoms into something else, fills them with energy. So it's like a gazillion types of information, and it's all right there in that one seed, wrote down on DNA strands that are made out of hydrogen. So very beautiful thing to understand in physics and everything. So, and because this is for just a few plants, a little bit of water goes in. I put in water that I buy at the store. That's good water from springs, you know, but you can use, if you don't have money for that and everything, you can use ordinary water. That's okay, because all these green stuff, as it is whizzed in the blender, they will even enrich the water with energy. See, when you pour this into a plant, that's not ordinary water anymore. That's like a juice that you're watering a plant with, because all this water in there will combine with the green energy and neutrons and everything from these greens, and then it's enriched even water, you know. So there it is, it has finished. And there's a lot of foam on top, and it looks sort of even whitish. But that's probably from the cream, milk cream, that's from the cactus. And I was very sad about cutting it. This is my favorite cactus. This is a Nevada type of cactus, Texas, Mexican type of cactus that's in the Western movies and everything. A very cool cactus, my favorite one. And I was even sad about cutting it. But people maybe don't know, cactuses do give fruit, you know, in some countries, in Asia and everything. And mine I'm watering with some light to make it big and to make it very good and everything. And it might even give some fruit, who knows, you know, if it's enriched a lot and made very good, you know, because some plants don't give fruits, but thousands of years maybe they did. There's just not any good enough atoms around to make that fruit anymore, and so on. So some old plants that don't give fruit, they might in the future give fruit when they're watered with some good, better stuff. So that's what one gets, a very green, very rich, the cold water type thing. Green and everything in there. And because this is for small plants, this is enough now. So there it is in the end. That's about enough for those 3 plants. Very rich, very green, and people can see right there, this looks like something you got out of Starbucks or something, you know. And through some physics, this is actually for old people, especially because they're missing a lot of this cold energy. For old people, this could be even very healthy to drink. Okay, so there it is, and now we go to the plants. Now the chili is a habanero chili, which is a Amazon type plant, which is usually originates from and used to hot temperature and used to not so cold atoms. So this will be maybe the first time in history that it is being made out of these cold atoms. But the chili plant is designed that way, that is totally used to a change in atoms. So it's used to that, its genes and so on. So then I just pour it in. People can see. Try to avoid the flour, because this is thick stuff and might mess it up. It's poured in, and that's about that. That much is probably enough. It's already pouring out, therefore it's even too much, because I didn't make it. And this chili too is gonna be that, and there it is. That's quite enough for it. I can see right there how down, but there it is, it's already pouring out. So I even made too much, but that's for next time. This stuff can stay, and it's not gonna go bad for like a month. It's not gonna go bad never, probably, this stuff. If you make drinks out of this stuff, you can keep it outside in the summertime and it'll never go bad and everything. Probably is the explanation. So that's how it's done. It's very simple and easy. People make this type of juice, you pour it in, and that's that. And every time you water, you do it like that. And that's all there is to it. So now they're watered, and that's that. And about every 2 days, one would have to water them like that. But that's not really that much a problem. This is totally little stuff and done very, very quickly. But the problem with these plants is that I was all in a hurry and everything, and I watered them with honey. And because their root system was so small, then I had to get them out of the land, clean the roots, and then replant them in new clean land. And that's all what I did. But when I was taking them out and cleaning the roots, I cut away a lot of their roots. But the roots will form fast, especially with enriched atoms. They'll form fast in like 10 days. The roots will get bigger and everything, and then they'll start growing very, very well. That too is important, how big are the roots of plants and everything. But because I had to replant them, and I cut away most of the roots, then they stopped growing. I mean, they're growing, but sort of slower. But in about 10 days, they'll pick up to grow fast again and so on. I mean, these plants that you see right here, especially that one, which will be the winter version, that one in September will be as big as the dinosaur tree. That's the same type of breed as the dinosaur tree right there. So that one will be as big as the dinosaur tree about in September, but in summertime they'll grow even more, so it'll be even bigger in September is the plan and everything. The dinosaur tree is now around over 3 meters tall and everything, and still growing very, very well and producing tomatoes and everything. But there is one thing I wanted to show to people. This is one tomato that I got from the store, a very, very big one and everything. And there is the size of these greens that are on the tomato. And this right here is about 3 centimeters right there, sort of around 3 centimeters. And I wanted to show people right here these. That sort of shows how big is the tomato gonna be. When you see these spikes coming out, these greens on top, so to me they look, these are still a little bit smaller because they haven't grown up that much. These are now that big, sort of as big as these. This one right there was 2 centimeters, 2 centimeters and 7. 2 centimeters, 0.7 was that one right there, the biggest one. And this one is about 3. But this one is a mature tomato. And that was growing with the tomato. So when these tomatoes are ready to take as fruit, when they're red and ready, these will grow then probably even more. So, and this is one of the biggest tomatoes I could find in the store. Although on the inside I can show people, you can see this. This is probably this white stuff. You see right there, it looks like it's some type of even like a greasy crystal. Not a crystal, but when you see this white stuff in a tomato like that, that's totally crap tomatoes. See, this is probably some chemicals or some stuff they put into it to make it big, but I only took the seeds out of this one. The seeds were very big and good for planting, and I planted some of them because I want to have a breed of these huge tomatoes. I just took the seeds. The seeds are okay, probably, but the tomato itself, it's not the tomato's fault. They just made it out of some total chemicals or some crap. But maybe that's because it's a winter tomato version, you know. But you know, they probably look to make, the bigger the tomato is, the more money it brings, you know. Some people look at it from that point of view. But when I tasted this right there, it was like it's garbage. Totally has no taste. It's like some totally chemical thing that's totally crap. But that's what I wanted to show people, these green spikes right there. This huge tomato has spikes like that. And these spikes are already that size. Plus they grow with the tomato, and so does the stem right there that holds it. The wood that holds the tomato, that too becomes bigger, people can see there, as the tomato grows, because it has to hold it. So these will get even bigger, you know. And some of my math and estimates told me that these tomatoes should probably be around maybe a kilogram each. When they're this type, I mean they are this type, but they should probably be a kilogram each, as I see it. Because these green spikes, this is when it's done and it's all grown up and ready to harvest. But these are just beginning and they are that size. So when it's done, they'll probably be even longer and longer and so on. So some of these tomatoes might even be like a meter, 1 meter, 1 kilogram. One tomato might weigh when it's done. But that's not because of any bad chemicals or how they do it, but because it's made out of the biggest, fattest, richest atoms, you know, like honey, like tuna, like egg. People don't know this about eggs, and why I use eggs. Eggs are 1,000 times better, plus they blend a lot faster, because an egg is like a unborn chicken, you know. So the egg atoms are like eggs, so they are totally young, therefore they are full of energy. But I buy many eggs, different types, for the plants and everything, not just chicken eggs, but good organic eggs and so on and so on. And there is many different eggs to buy and so on. Sometimes when I water this plant, the one watering goes up to even like €4 per watering. And now I'm even introducing tuna fish in some of them, which is even adding to that. But that's okay. People don't have to do that. If it's too expensive for somebody. The forest things that some of them that I mentioned, and this cold nitrogen things is also extremely good to make very healthy fruit. This cold that I explained how to water this. Okay, with cactus and everything, you can even water tomatoes with this, and they'll be extremely enriched cold stuff. The tool returns you through physics and everything, and will make very good tomatoes and healthy and everything and so on. I mean, they'll be tons better than this stuff people buy at the store and everything. But I thought to show this tomato because of its size. This is like a very big tomato, and I cut off half of it almost. But thought to compare right there, people can see that the spikes are almost the same size already. So that means these tomatoes will sort of be this size, maybe even bigger. But they will be extremely rich and made out of bigger atoms, so therefore they'll be even bigger, but they'll be totally 100% organic and healthy. That's the important part and everything. And this is about the size of tomato that I got the seeds out of when I took the seeds for these plants and everything. So these I measured are about 2 centimeters, 0.4 are these spikes. And this is some strange one. It has these yellow parts right there and so on. But so these are already bigger than that. And this is the size of tomato they're on. So that's sort of showing, and right there they are growing like very good, but that sort of indicates how big is the tomato gonna be. But these green parts and these wood parts on top that hold the tomato, they also get bigger and bigger as the tomato grows, because the wood has to hold the size of the tomato. I mean, the whole plant gets bigger, of course, especially in the summertime when it's hotter and everything. But that's right there, the wood. So it's fatter even on this little tomato than it is here and so on. And these are now all fertilized on this whole part. So that's like 6 tomatoes right there growing. And there's that little tiny one, but that one will probably start in the summer or something. It too is green and very healthy, but probably all the energy is going into the fruits. And now I turned on the climate tonight to leave it at around 27. for all the tomatoes to increase speed of production. So that's about enough. No higher than that is needed for tomatoes, because the best temperature for tomatoes, people say, is around 18 to 27 degrees. But now I increased a little bit heat, and at nighttime I might put it around 24, and then that's that. But that's gonna help dry out the ground faster. Therefore, all the moisture will go evaporate into the air. Plants will inhale it and will go into the roots faster, and so on. And then it's watered then next time faster, and the process goes faster. But with tomatoes, it's not really that smart to water it fast. Sometimes it's even good to leave maybe 10 hours the tomato dry. When it's dry like that, although here it's only dry on the surface. So sometimes it's okay to leave it like that dry, maybe for 5 hours, so to speak, because there are a lot of roots right there even seen. And this tomato plant, because the whole pot is full of them, but it's okay to leave it dry a little bit, because even then the tomato picks something up, the tomato plant, that gives it sort of some nice sort of flavor and so on, you could say. But it's okay to do that for like maybe 5 hours, 10 hours, and then water it and so on. But now I turned on the climate, and I'm gonna see, is it gonna help? Because these days I didn't do that at all, because it was hot, but at night it isn't. At night it gets cold, below 18 degrees, so then that's not even good for tomato plants and tomatoes. And now I'm gonna see first night how things are going with the climate on 27 degrees, which I'll drop later to 24.